cooperation. This workshop brings together experts, researchers, and policymakers to address one of the most critical challenges of our time, optimizing water productivity. As global water resources face increasing pressure from population growth, climate change, and competing demands, innovation and collaboration are essential to securing a sustainable water future. Today, we're not only here to explore innovative approaches and strategic cooperation, but also to celebrate a remarkable milestone. This year marks the 50 years since the establishment of the National Water Research Centre, an institution that has remained at the forefront of the water research and policy support in Egypt. Established in 1979, the NWRC serves as the research arm of the Ministry of Water Resources and Irrigation. For half a century, it has been committed to advancing sustainable water management through research, innovation, and capacity building. As the backbone of water research in Egypt, the NWRC has shaped national policies, developed strategic solutions, tackled emerging water challenges with dedication and scientific excellence. NWRC's mission goes beyond research. It plays a fundamental role in guiding the nation's efforts towards integrated water resources management, ensuring water availability, quality, and sustainability for future generations. Over 50 years, NWRC has achieved significant milestones to continue to shape Egyptian's water management landscapes. It played a pivotal role in advancing rational water use, pollution control, and development of new resources. NWRC also supports the ministry in its ongoing efforts to improve water efficiency under Irrigation System 2.0 initiative, which includes modern irrigation projects, water treatment, and digitalization of water management. The NWRC has played a key role in managing Egypt's water resources by leading innovative projects that promote efficient water use, particularly in agriculture. Through advanced irrigation techniques and smart water management practices, the NWRC has successfully shared in reduced water consumption while enhancing the agricultural productivity. The center's structure includes 12 specialized research institutes, a central laboratory, and several dedicated units, each focusing on a critical aspect of water resources. These institutes cover a wide range of topics, including irrigation and drainage, hydraulics, river engineering, surface hydrology, groundwater hydrogeology, sediment transport, coastal protection, and climate change. Through this multidisciplinary approach and advanced research capabilities, the NWRC has established itself as a cornerstone of scientific knowledge and innovation. As we celebrate 50 years of excellence, we honor the achievement of the National Water Research Centre dedicated researchers, leaders, and staff. Their unwavering commitment continues to safeguard Egypt's most vital resource. Through these decades, NWRC has played a crucial role in shaping national water strategies, developing innovative irrigation techniques, and advancing applied water research. NWRC has also demonstrated leadership in international collaboration by forging partnerships with global and regional water organizations to promote knowledge exchange and capacity building, reinforcing its role as a leader in water research and management. This golden anniversary stands as a testament to the dedication and vision of the National Water Research Centre's researchers and leadership in advancing sustainable water management. As we gather today to discuss enhancing water productivity, it is inspiring to reflect on how far we have come. NWRC's legacy is not only about research, it's about making a lasting impact on communities, ecosystems, and on the future of water security. Let's take this opportunity to honor the achievements of the NWRC while also looking ahead to the next 50 years of innovation and collaboration. I would like to extend my sincere gratitude to all the participants, speakers, organizations for their valuable contribution to this workshop. Your commitment to improving water productivity and fostering strategic cooperation reflects the same spirit of progress that the NWRC has championed for half a century. And now, please join me in expressing our sincere appreciation for the continuous support of the FAO in advancing sustainable water resources studies in Egypt. I would like also to extend my gratitude for the FAO for co-organizing this workshop. And now, it's my pleasure to welcome Ms. Jacqueline Bennett, the Program Officer of the FAO, to share her opening words. The floor is yours.
Distinguished guests, Your Excellencies, colleagues, representatives, friends, good afternoon, greetings, Ramadan Kareem to everyone. It is incredibly a big honor and a privilege to stand here in front of you. I am a program officer at the regional office, but I have also been recently asked to join our FAO Egypt team to support the country office. So it's really a pleasure to start meeting colleagues at the country level that we partner with. So it is a huge privilege to stand here next to you and help open the next 2 days of our workshop. So again, as our earlier speaker had said, I wish to thank NWRC, the National Water Research Center, and before that, I wish to congratulate you on your 50th anniversary. I hope we continue working together and we continue the good work that we have been doing together through our partnership. Indeed, water is key to sustainable development, and it's a key priority for us. Not just for FAO Egypt. Our region is in fact home to at least 5 of the worst food insecure countries, of the most food insecure countries in the world. At least 5 of them. We are very lucky, none of that is Egypt. However, the impact of food insecurity and hunger transcends boundaries, much like water. And for us here in Egypt, we hold a key responsibility for that because we, in addition to the threats and shocks and stresses that we have in the country, we are also home to a lot of the populations around us that come to Egypt. So hunger, food insecurity is a shared concern, as much as water is a shared concern. And why is that? Because our agriculture in Egypt very much relies on water, and our water here in Egypt is also shared across borders. So there's really no just one issue that stands alone. And one of the big responsibilities that we have, in fact, is to make sure that we are in a position to pilot, to research, to look for innovative technologies, to find the best practices, because we are in a position to do that in the country. And we are in a position to inform not just ourselves in Egypt, but also influence policy, strategies, and programs in other countries as well. And that's a huge responsibility for us here in Egypt. But however, these next 2 days is going to be a sharing of best practices, innovative ideas, new technologies, from AI to drone technology to using modern irrigation techniques. There's a huge opportunity to learn from each other here. And I would really, really encourage everyone to do that, collaborate, take note of the good practices, take note of what lessons we can take for our own projects and programs that we could do better. Not only replicate, but actually do better. And not repeat the models that maybe didn't work, and maybe ask ourselves as well how we can improve. And with that, I really want to appreciate the work of the Water Research Center, because as our introduction mentioned, research is the core of innovation. We learn from finding out what works and what doesn't work, and evidence is key to good programming, good well-informed food security strategies, well-informed development strategies. And again, I appreciate very much the next 2 days. I'm actually looking forward to learning from the lessons, from the case studies, and from all our speakers and presenters. So I really congratulate you and hope to have a very good exchange. As speaking from FAO and the regional office, and also FAO, the organization, we remain committed to this cause. We remain in partnership with you. This is not only at the country level, the communities, and working with the national partners, but we're also doing this globally and also in other regions. So there will be opportunities for us, even also us, to learn and be informed from this workshop. So again, very much welcome to everyone. I hope we have a fruitful next 2 days of sharing and discussion. We come up with joint action, joint policies, joint programs. And again, thank you very much to the Water Research Center, and shukran.
Thank you, Ms. Bennett, for your sharing your notes, your advices you offered through this 2 days workshop for all our participants to benefit the maximum of this workshop. Okay, and now it's time to join me to invite, please, Professor Sharif Mohammadi, the President of the NWRC, to deliver his opening notes.
السلام عليكم جميعا. Good afternoon. كل عام وانتم بخير. رمضان كريم. It's really a pleasure to welcome you all to this workshop. I mean, all the distinguished guests, the esteemed colleagues, and the valued partner. This is a very important workshop for us, which is titled Enhancing Water Productivity and focuses on innovation and strategic cooperation. And of course, the title itself represents how we are valuing the water and its productivity, but also how to properly manage it and better think about the efficiencies that we are using our water. So this workshop, which is actually jointly organized by the National Water Research Center and the FAO, it's really one of a series of workshops that we are planning at NWRC to do and organize jointly with our partners to highlight hot issues related to water, but also to recognize the value and the knowledge available within our community and our research systems and universities and also implementing institutions that we need to gain and capture and build on. So let me first to extend my sincere gratitude to FAO and the Ministry of Water Resources and Irrigation to Egypt for their invaluable collaboration in organizing this event. I also wish to acknowledge the presence of government officials, international organization representatives, academia, and civil society organizations. Your participation in this workshop is a testimony to the urgency and importance of addressing water productivity challenges. So this year's marks, as just mentioned by Dr. Iman, a significant milestone of NWRC, our 50th anniversary, 50 years anniversary, and for 5 decades, NWRC has been at the forefront of scientific research, technological innovation, and policy development in water resources management. Throughout these years, we have worked to enhance water efficiency, improve irrigation methods, promote wastewater reuse, develop climate adaptation strategies, and strengthen Egypt's resilience to water-related challenges. Our research has been the foundation for major national water policies and projects, contributing directly to Egypt's water security and economic development. This workshop is one of a series of events planned throughout this year to celebrate NWRC legacy. It also reflects on our achievement and also set the course for the future. As we mark this milestone, we reaffirm our commitment to driving cutting-edge research, fostering collaboration, and developing real-world solutions to Egypt's water challenges. We all know that today the world is facing an unprecedented water crisis. Climate change, rapid population growth, and increasing demand for water have placed immense pressure on water resources. Agriculture alone consumes more than 80% of Egypt's water resources, and yet inefficiencies in irrigation and soil management persist. If we are to ensure food security, economic growth, and environmental sustainability, we must take decisive action to maximize the efficiency of every drop of water. This requires an integrated approach that combines scientific research, innovative technologies, effective policies, and strong collaboration among all stakeholders. So this workshop aims to tackle these challenges head-on, bringing together experts from different fields to discuss practical solutions, share best practices, and develop actionable strategies to enhance water productivity. We at NWRC, we don't conduct research for the sake of research. We believe that water-related challenges must be addressed through problem-driven, multidisciplinarity, and collaborative research. So our strategy is built on mainly 3 pillars. 1, a holistic research approach. We integrate engineering, hydrology, environmental science, economic, and social science even, to provide comprehensive solutions. Water management is not just a technical issue. It is a social, economic, and environmental imperative. 2nd, collaboration and partnership. We actively engage with government institutions, universities, international organizations, private sector partners, and local communities to ensure that our research translates into real policy and implementation and tangible results. 3rd, real-life problem solving. We are committed to orienting our research towards practical applications that directly impact agricultural productivity, climate resilience, and water security. Our work on smart irrigation, AI-based water monitoring, and water reuse strategies has already influenced national water policies and contributed to improving water use efficiency. And this workshop reflects NWRC's strategic vision as it provides a platform to foster collaboration, exchange knowledge, and develop solutions that can be implemented on the ground. So over the next 2 days, we will focus on scientific, technological, and policy-driven approaches to enhancing water productivity. This workshop is structured around 7 critical themes, addressing both technical innovation and policy solutions. In day 1, under the title Science and Technology for Water Efficiency, we will tackle modern irrigation techniques and soil management, water reuse and recycling, artificial intelligence and drones as innovative tools for real-time water resources monitoring. On the second day, day 2, it will focus on climate resilience and capacity building and policy solutions. Through session for climate change resilience in agriculture water management, education, awareness, and capacity building effort to empower stakeholders with knowledge and skills. And 3rd, international cooperation and policy development to ensure that research and innovation translate into actionable strategy. This comprehensive agenda will ensure that we address water productivity from multiple dimensions: technical, economical, environmental, and also policy related. Ladies and gentlemen, the challenges we face require collective action. Water productivity is not the responsibility of one institution or sector. It is a shared responsibility that demands strong partnerships. Policymakers must create an enabling environment for sustainable water management. Scientists and researchers must provide data-driven solutions and innovation. The private sector must invest in and adopt water-efficient technologies. International organizations must support capacity building and knowledge-sharing initiatives. As we embark on this workshop, I encourage all of you to engage actively, share insights, and contribute to shaping practical and implementable solutions. At NWRC, we are committed to supporting the implementation of the ideas and strategies that emerge from this workshop. As we look ahead to the next 50 years of NWRC's journey, we pledge to continue our mission of advancing research, fostering innovation, and driving real-world impact. In closing, I would like to once again thank FAO and the Ministry of Water and Irrigation and all our esteemed partners for making this event possible. I also thank each of you for taking the time to join us in this critical dialogue. Together, let us build a future where water resources are managed efficiently, equitably, and sustainably. The time to act is now, and I wish you all a productive and insightful workshop. Thank you so much.
Thank you, Professor Shereen, for emphasizing on our major contribution and our experiences in the National Water Research Center over the past 50 years. And also thanks for highlighting how we work, our strategic vision at the NWRC, and the main pillars which we act accordingly. And also thank you for shedding light on this two-day workshop and giving a brief for all the participants to see what are we expecting these 2 days. And now it's my pleasure to introduce our esteemed first speaker for the session titled Enhancing Water Productivity Project, this event that we are tackling now. Today we're honored to have Engineer Mohammed Ibrahim Abdegawed, the head of the Irrigation Improvement Sector at the Ministry of Water Resources and Irrigation. With over 25 years of experience in this field, Engineer Mohammed has held several leadership positions, including Undersecretary of the Ministry in Fayoum, General Director of Irrigation, Venezuela, and WEN Administration. He also has an extensive background in water allocation management, canal rehabilitation, modern irrigation implementation, and control structure management. Currently, he's the head of the Irrigation Improvement Sector, and he's leading the transformation from traditional to modern irrigation techniques to maximize the agriculture productivity per unit of water. Please join me in welcoming Engineer Mohammed.
بسم الله الرحمن الرحيم. برحب بحضراتكم جميعا وكل سنه وانتم طيبين ورمضان كريم على الجميع باذن الله. ليا الشرف ان انا اكون مع حضراتكم النهارده وباذن الله تعالى احنا هنتكلم عن enhancement of agricultural productivity in Egypt, and we heard from the beginning. In the beginning, we were talking about water resources in Egypt. In the first, we have challenges, look like increasing population density, growing demand supply gap, because now there is a big gap between the demand and from water and the population in Egypt. Inadequacy of available governmental investment, poor and cost recovery, pollution resulted from industrial growth, high cost and lack of power sources in Egypt, low level awareness for participation between the farmers, increasing environmental concern. According to that, we have a lot of results, look like decreasing per capita availability, degrading water quality in many places in Egypt, increasing competition and conflict within sectors and within society, increasing competition and conflict among farmers and with the environment, negative effects in irrigation efficiency. So, Ministry of Water Resource and Irrigation Strategy towards modern irrigation. We are going to apply modern irrigation system in reclaimed lands, the area of which was estimated by the survey work was about 500,000 faddan at least, and it is become bigger and bigger today according to the farmers' behavior. And we are going to apply modern irrigation, drip irrigation in sugarcane. Commanded area is about 325,000 faddan, including the improvement of tertiary canal MESA with a single lifted pointing system. Applying modern irrigation improved orchard command area of about 750,000 faddan, but we are waiting now for a lot of studies for this orchard area because we don't have till now a final study for how to apply that without have problems in trees according to the change this behavior of water to drip irrigation one time directly. Implementing developed surface irrigation in the northern region of Delta with a total command area of about 1.6 million faddan. The rest of the Delta and the Valley region with a total about 2.7 million acres developed surface irrigation, modern irrigation according to the farmer design. After that, we are going to concept of irrigation improvement project on all the land. We are using one lifting point now when we make a new project because according to the system of irrigation in Egypt, we have the main canals, and from the main canals we have branch canal, and from the branch canal we have MESA. If the MESA is about 25 to 50 faddan, we make one lifting point directly on branch canal to make it. This is the first method. We collect all the farmers in one lifting point to develop this way of irrigation. If we have many farmers take water directly from the branch canal, we collect them in one lifting point direct on the branch canal. If we have a big MESA, more than 70 faddan, some MESAs in some places or Marawi, about 200 faddan or 300 faddan. So we collect farmers on the mark. Every 50 faddan, we collect them in one lifting point on the Marwa because we can't make stations for farmers more than 50 faddan because it has a very big cost. So we collect them in 4 places or 5 places on the Marwa to make one lifting point system on the irrigation. Challenges. Fragmented small land holding or individual farmers, implementing modern irrigation without rehabilitation of the convenience system of the irrigation scheme, forming a committee, sharing operation, maintenance, cost, irrigation scheduling, start-up capital or access to credit facilities, lack of local manufacturers of modern irrigation equipment, water quality issue in branch canal, high pressure and energy cost for pumping water, salt accumulation problems in the root zone. So we have our project in irrigation sector. This project is called Enhancement of Agricultural Productivity. The main implementing partner is FAO, is responsible for implementing this project on the land. And we have the fund from Japanese government. And the total budget for this project is $3.7 million. Location, we have 3 governments in Egypt, Kafr Sheikh, Minya Hina, Hayat Karima district. Start date 1st of April 2023 and the end date 31 March 2025. The main partner is the main implementing partner is FAO. Ministry of Water Resource and Irrigation is the governmental partner, and we have cooperated with Ministry of Land Reclamation and National Water Resource Center and the Regional Center Training Water Sector and the Total University and ICAR. Project objectives: strengthen smallholder farmers and building their capacity, reduction of poverty and building resilience, improving water utilization and increasing agricultural water productivity, creating economic opportunities for poor rural households, promotion of modern irrigation techniques and crop diversity, promotion of climate-smart water management, consideration of the water energy food nexus. Project outputs: irrigation modernization is demonstrated to optimize energy use and water productivity. Capacities of smallholder farmers are enhanced to effectively promote modern irrigation technologies and participate in line with GAP principles through farmer field school. Technical knowledge and skills of small farmers enhanced to effectively promote sustainable irrigation and effective participate through the implementation of farmers field school. Smallholder farmers engage in sustainable income generating activity and their income increased. Project achievement: implementing modern irrigation pilot in Minya and Hina. We have 2 pilot areas. We made modern irrigation in this pilot. Ganabet Khuzam Canal in Hina government. It's about 40 faddan. We have 31 farmers. Sugar cane crop. We made drip irrigation network, solar energy. And we made Farag field. Minya government, about 46 faddan, 37 farmer, variety of crops in this area. We have drip and sprinkler irrigation network with solar energy for them. After that, we have implemented 10 greenhouses, 6 greenhouses in Kafr Sheikh, 2 greenhouses on fresh water source, 2 greenhouses on mixed water source, 2 greenhouses fed faddan from fish farm, aquaponic. 2 greenhouses in Minya government and 2 greenhouses in Hina government. Impact assessment of using modern irrigation and solar energy, environment, financial. Total University in a collaboration with National Water Resource Center take a survey for 15 farmers were selected to conduct data collection and analyze. Main parameters to measure: water use efficiency, crop production, farmer net profit from cultivation, and water quality and soil salinity. And we made also raised bed machine in collaboration with Icarda. 5 raised bed machine is we give them for water user organization in Kafr Sheikh to work with it, and we deliver it to the water user organizations, locally manufactured, distributed to farmers benefiting from the project, and we make training for them in the regional water resource center to how to use it and how to take all the benefits for all water user organization in the area in this project. Also, soil salinity leaching in collaboration with Icarda also, 5 sites in Kafr Sheikh, soil salinity leaching by creating a network of interior canals connecting from external canals into fields, parallel internal drain connecting from the fields into external drain towards the land. And we have a good experiment in this, because when we do that, this land, we take 6 months for washing this land, and after that we cultivate it, and we have a good crops from it now, and the farmers will apply it in another area in Kafr Sheikh. Project achievements: agrivoltaic for sustainable agriculture in collaboration with Icarda also, 5 sites in 3 target governments. The partial shade protects crops from extreme hard and reduce water loss. Anti-tracing increase crop yield, reduce water consumption, and reduction of irrigation cost. Project achievement at last: training and farmers field schools, training in Japan, training course, irrigation network design, and water systems. We conducted a tutorial university in Japan for 19 engineers from the ministry. Farmers training programs for farmers in the field, operation and maintenance of modern irrigation networks were implemented for 1,200 farmers through the regional center training. Farmers field schools training and capacity building, farmer field schools, about 57 farmer field schools, about 1,400 farmers. Technical staff training, 2 training package for 30 engineers in the field, design, implementation, and maintenance of modern irrigation networks at the regional central training water sector. And many thanks for you.
Thank you, Engineer Mohammed, for this comprehensive overview over the entire project, having first the status of the water resources in Egypt and the challenges that we're facing, then the strategies that the ministry is working towards it in the aspect of modern irrigation, and how this modern irrigation is being applied, and then the challenges on this application also, because it's challenging. And later, thank you for shedding light on the overview of the project, budget duration, the implementation locations, as well as the partners, also the project objective, outputs, and achievement on land for the pilots in Minya, Kafr Sheikh, and Qina, and also the impact assessment that has been conducted environmentally and financially, and also in sharing the capacity building activities that has been conducted through this project for the farmers and the engineers. Thank you again. And now, please allow me to welcome Dr. Alauddin Hawiya. He is the country coordinator for the Nile Valley Program at the International Center for Agricultural Research in the Dry Areas, ICARDA. Dr. Alauddin has over 25 years of experience in agricultural research. He's the senior scientist breeder for drought-tolerant crops, especially strategic crops. The floor is yours.
Thank you. Good afternoon and Ramadan Kareem. Bismillahirrahmanirrahim. Thank you for inviting Icarda today to this land. And the center was established in 1975, so already also 15 years. We should celebrate this year for ICARDA. And after 5 years of the establishment in Aleppo, in Syria, ICARDA opened the regional office in Egypt. Because the region, ICARDA covered from the central Asia, from India up to West North Africa in Marrakech, in Rabat. So in Morocco. So we have 15 set the office, regional office. But the first one was open for ICARDA outside the center was in Egypt, because all this region is the agriculture is based on the rain-fed agriculture, but in Egypt it's irrigated. So for us it was like a new research we have to do in Egypt. And since that time, I think in 1980, when we came to Egypt, Egypt was only 60 or 65 million, the population today is 100. And we know that the water resource is limited so for Egypt. And this makes more stress on us that we need to benefit from each drop of water to increase the productivity. So we work in ICARDA with the strategic crops, wheat, barley, lentil, fava bean, chickpea, and among these crops I mentioned, fava bean and wheat, this is the daily food for Egyptian. So we, at the beginning, we try to improve the productivity and the drought tolerant. We provide new germplasm to the Egyptians to test under drought tolerance condition. But today we see that our research in water is important. Therefore, our partnership with the National Research Center, National Water Research Center is essential, and I'm really proud to see ICARDA have contributed important project. Hopefully, with this collaboration with the scientists in Egypt, we will be able to produce, to develop technologies that not will benefit only Egypt, but also we work with, as I said, in a huge area in the region, so we can also transfer the technology. 3 weeks ago, I was in Syria. Syria now trying to, make the agricultural rehabilitation of the agricultural sector, and I said, let's benefit from our brothers in Egypt, because they have also developed very nice systems. So we see now we talk about smart agriculture, smart irrigation, the drought report, and also the mega project is all aligned with the government's plan to expand agriculture in the desert. And we see this mega project dropping this water from the north to south to Start Masr. ICARDA also tried to provide such solutions, because this is also environment it's another challenge than what we see in the valley. Therefore, we, for example, provided barley, our varieties or germplasm on barley, which can help to grow under more saline soil than wheat, and also produce the products that could be also used in the producing palatine bread. So such solutions together with this partnership, I think we can make the impossible possible with your help. Thank you very much for the invitation, and good luck with the workshop.
Thank you. Thank you, Dr. Ali, for sharing brief the history of the ICARDA and the strategic efforts that it has been conducting all over the world, and also especially in Egypt. Okay, and by now it's time to finish our first session. So let's make the most of these 2 days by engaging openly, sharing knowledge, and building lasting connections, as together we continue to pave the way for innovative solutions and collaborative efforts that ensure water's secure future. Thank you once again for joining us, and welcome to the workshop. And please allow me first to ask to the floor the first session participants. The session is entitled Water Irrigation Techniques and Soil Management. The session will be moderated by Dr. Shireen Asif. Please join us at the floor. And the participants of the first session, Professor Abdelazim Bilal, Professor Abu Khair Badawi, and Professor Muhammad Sahib. And please, Dr. Abdel Hamid, join us. The floor is all yours. Thank you.
It's my pleasure to join you today for this important session, which is we are going to explore the ways of rationalization of water and the strategies that Egypt has been put for rationalization of water and increasing the efficiency of the water sector. Actually, the water scarcity is one of Egypt's most pressing challenges, with the country facing a growing population, the growing gap between water demand and the supply. The river Nile in Egypt is the primary freshwater source, and it remains constant in flow while population growth, agricultural expansion, and industrial development continue to increase in Egypt. As all of you know, that 80% of Egypt's freshwater share is used in the agriculture sector. So that this session aims to address the critical needs for rationalization of irrigation water and that is being used in agriculture sector, which employs also 30% of the workforce and support over half of the population. Let me give you an introduction about the use of water in the agriculture sector. Actually, efficient water use is vital for sustaining Egypt's agricultural productivity with limited resources and climate change impacts. The current irrigation practices often lead to water waste, inadequate distribution, and high cost. You know that flooding, for irrigation is wasting too much amount of water. Rationalization efforts can mitigate these issues by improving water use efficiency, reducing pumping cost, and enhancing crop yield in agriculture. Furthermore, modernization irrigation techniques such as drip irrigation, hydroponics, can offer promising solutions to save water and improve the outputs. Actually, Egypt has already made development in irrigation modernization through projects like converting open canals and belt pipes and introducing advanced pumping systems. These initiatives have benefited hundreds of thousands of farmers by reducing water losses and improving access to the tail end of canals. Such strategies for further implementation are being implemented to fully address Egypt water challenges. Some strategies have been made, such as expanding modern irrigation methods such as sprinkler and drip irrigation systems, promoting farmer participation through water user association to optimize water distribution, integrating technologies like hydroponics to save water and fertilization while increasing agricultural exports, enhancing infrastructure with dedicated electricity grids and irrigation systems, and also exploring alternative measures such as desalination and groundwater management. Through these strategies, Egypt can ensure sustainable agricultural growth while safeguarding its precious water resources. This session will be a good chance to dive more deeply in these aspects to foster dialogue on effective solutions for rationalizing irrigation water in Egypt. Let me first invite our first speaker for this session, Professor Dr. Abdelaziz Bilal. Dr. Bilal is a professor of soil science and precision farming. He is the Vice NERSS Chairman for the Technical and Administrative Affairs. He is the acting head of Agriculture Application, Soil and Marine Division. Dr. Bilal also is the President-elect of African Association for Precision Agriculture, National Authority for Remote Sensing and Space Sciences. Professor Bilal obtained his PhD in the field of precision or smart agriculture using remote sensing and geographic information systems from Freiburg University in Germany in 2006, and also from 2006 and 2007. He received his grant from China government for postdoctoral studies in the Institute of Remote Sensing and Information Application in Agriculture, Faculty of Agriculture in China. Also from July 2008 to September 2008, he was a postdoctoral, he has gained a postdoctoral grant and obtained from the Egyptian government in the field of precision agriculture, Faculty of Life Science at the Copenhagen University in Denmark. Also, from December 2009 to January 2010, he was a visiting professor scholarship. Scholar was obtained from the day1 in the Institute of Photogrammetry and Geoinformatics, School of Aerospace and Surveying Engineering, University of Stuttgart, University in Germany. Professor Bilal also has many experience in the application of remote sensing, artificial intelligence, Internet of Things, all of these new technologies which are being very important nowadays, and also the information communication technologies, the ICT, geographic information systems, and models in the following fields like irrigation, water management, precision agriculture, smart irrigation, sustainable agriculture development. Also, Professor Bilal is involved in research of pedometrics, proximal soil sensing, soil spectroscopy, digital soil mapping, soil degradation, and desertification and land evaluation. Professor Bilal is a supervisor for more than 30 masters and PhD dissertations in various Egyptian universities, and also he is a PI and co-PI or member in several national and international projects. Dr. Abdelaziz Bilal, welcome to the workshop, and the floor is yours.
شكرا دكتورة شيرين. طبعا في البداية أنا بشكر المركز القومي للبحوث العلمية على الدعوة إن احنا نعمل جزء من اللي هي استخدام النيو انفورميشن تكنولوجي بالتعاون مع وزارة الزراعة ومحافظة الكليات في تطوير نظم الزراعة الذكية. احنا بنطور نظم الزراعة الذكية اللي هي نظام الري بما يتعلق بورشه العمل يعني. فاحنا طبعا هنا هنتكلم على الافيشنت irrigation اللي هو develop smart irrigation based on remote sensing artificial intelligence IoT under Egyptian condition. ده عنوان المحاضره. نجس. احنا طبعا دلوقتي في برضه هنا الدوله مهتمه جدا يعني ان احنا نحقق اهداف التنميه المستدامه. واهداف التنميه المستدامه عشان اعمل الديجيتال ترانسفورميشنز خصوصا في الagriculture او اعمل achievement for sustainable development goals. We can use artificial intelligence in different goals of sustainability. Today we speak about agriculture, life on land and water. Through objectives we can use it artificial intelligence beside other technology IoT. Very important today, all the people speak about the evaluation, agricultural evaluations. Now the people speak about evaluation, agriculture 5.0. In this year, 2025, agriculture 6.0. But if we see now, NAS working in agriculture 4.0, can use solar energy and the electric and AI and IoT. This is the evaluations of a smart agriculture. That we should in consideration what the development can be work and what is the Egyptian can work now. In our authorities, we work in agriculture 4.0. We can use smart agriculture such as artificial intelligence, internet of thinking, new energy, solar energy. We use it to development the systems. Next. Now we have the data. If now we need to build the systems for to increase the efficiency, for example, of smart irrigations, we need to collect the data. We have different sources for the data, from drones, satellite data, from weathering stations, and after that we need to make a preparation for the data. After we collect the data, this is data source, we need to make preparation for this data. After that, make processing and make modeling. After we make modeling, make decisions. This is decision for. After that, make service for farmer, for agricultural research, for governmental agricultural sectors. This is you will show if we need to work with the smart or with use smart agriculture or smart irrigation. We need to move this process to achieve. And the main target for us is the service for farmer or agricultural research or governmental agricultural sector. Next. What is the IoT unit in different sectors for agriculture? For soil monitoring sensors, now when we speak the soil moisture sensor, which can advance the methodology for increase the efficiency of irrigation water management. Also the machines, we also have to make it connected and collect the data and transfer the data. How to can, if we have drones, we need to connections with the drones, need the internet of things. Some people tell us we have a problem in Egypt for some areas don't have internet. Now the people in developed country develop the satellite for internet of things to collect the data. Next. Now, if we need to make a definition for smart irrigation management, right input in right time, in right amount, in right place, in right manner. This is very important things for if we need to do smart irrigations or smart agriculture. It's a different application of smart. Other things, what is the benefit for, now we speak about also climate change. If we see smart or precision agriculture can mitigate the climate change, okay, can through the optimize the input regarding the spatial and the temporal unfold variability within the field. This is very important to can mitigate the climate change. Next. What is the benefit of smart irrigations? the yield production of the farmer in case. Reduce environmental pollution through the agrochemicals. If we need to make fertigations with, and both what is the planet need can make reduce the pollution. Increase the pressure of population target. If we need to make the smart irrigation, we need to make all information on the farm. You have database, completely database on the farm. Precision agriculture or smart irrigation, make mitigation, and we develop a system for the rice, irrigation rice. This is one of the main of methane gases, emissions. This is who can mitigate the green gases emissions. This is we have three gases, nitrous, and also methane and carbon dioxide. If we see the rice, we concentrate the rice, now we develop sensors to save the water around 30%. This is can reduce methane emissions. Also, we develop other sensors for smart irrigation for other crops. This is the three gases emissions from the agriculture, and this is for carbon dioxide can also, and the methane emission can come from livestock farm. Now if we have the smart irrigation system, we have a valve, contain valve control, flow meters, wireless connectivity, and the power source. This is the components of the systems. But in traditional systems, grower will manually open and close the valve. And we also, in Egypt, we know that traditional systems, so sprinkler or drip irrigation or flood irrigations, but not just to meet the requirements, what is the requirements of the planets, but any smart, if some places have increased soil moistures and other less, we put what is the need, and based on the spatial variability of the soil and the spatial variability of planet. Because we have to, if we now to speak about the smart irrigation technology, we have two climate-based controller, weather-based. We need to calculate evapotranspiration, evapotranspirations, and the other one on-site soil moisture sensor. Soil moisture sensor control, second type of the smart irrigation. This is the two types if we need to apply the smart irrigation. But for the soil moisture sensor, we have to calculate the barometric water content and the threshold. What is the time and the place can put and open the valve to put the water. This is the two system. This is one new controller, climate-based controller, and soil moisture. This is add-on sensors, soil moisture sensor, rain and wind sensors. This is weather stations. This is the diagram, the schematics for the drip irrigation, smart drip irrigation. We put sensors. We have weather station to calculate the data, and the soil moisture sensors for different goals, and we can open and close the valve and put the requirements of planets. That's the other one for sprinkler irrigations. As the same, we have the sensor. Sensor collects the data about the soil moistures and make analysis, and put this in cloud, make web application or mobile application and so on, and can make open and switch automatically, fully automated control systems. This is it's a dream for us how smart agriculture works. Now, if we need to see the rates, different soil moisture can put, for example, the D, that's meaning zero application rate. We have water. We don't need to put the water. We have this same, we'll see you, we have the same in our country. Now we go to the desert, all the people see the desert is the sand. But this is, I think, from my background, desert is the sand what we have the shale, or heavy clay soils. And the heavy clay soil shales can make absorption of the water and make waterlogged areas. That is the smart irrigation for sprinkler or for drip irrigation can make safe the water and increase the yield. Next. This is the image we need to show you how the traditional sprinkler irrigation work in 6 October company. This is the private company in Ismailia. This is in black points. This is a waterlogged area. This is shale. Have make much more absorbed water, and the yield is nothing yield. But now is that smart irrigation is very important, and you can monitoring the farm through the remote sensor. If we need a plan for smart irrigations, we need to consider the soil types. Soil type is very important. Not if you now go now the government make reclamation for the project, but consider what is the soil type. Desert, not is the sand. From by background, I am so scientist. If we don't say now is the futures, مستقبل مصر or the new delta have shales. If we do implement this one, or Toshka, or Shakil Estel Wainat had shales. This other soil had sandy soil. In the same field, 150 fatals, you can find different type of soil. We should considerations the soil variability based on the soil type. Next. This is just how to collect the data. We have sensor, and this is very important for us to make application for prescriptive maps. It's this one to collect all this data to make variable rate irrigation. You should have variable rate irrigation. This is can collect. Next, I'll show you in more details in the next one. This is a soil moisture sensor. This is one system. This other system, we speak about the weather. We have collected this data and produce variable rate irrigation map. 0, no water. 1 and 2 and 4. 4 is much more water you can put it, and we can show you some feelings about this one. Next. In Egypt, with the cooperation with Electronic Research Institute, we developed 4 sensors. One is more important sensor, the soil moisture sensor for smart irrigation, and makes the application on mobile applications. This is a system we have microcontroller and communications, can put it in PC and also cloud-based and transfer the data. This is our first system. Also, this is a system, and we can, from the mobile, we can make off and on and make it. Both the water, this is a schematic diagrams for the system which is developed in NAS cooperation with the Electronic Research Institute. This is where the validation is a system, and we work with solar energy, and also we have other options with electricity, and we make a validation for the system and make it submitted for patent. This is a system. This is the first one system we developed at NASA with a cooperation with the Research Electronic Research Institute. Now, this is the next one. It's very important. Now, for rice have much more water. They can save around 30 to 35% of water. This is a project funded from Academy of Science of Egypt. And if we see this is a road zones, half is waterlogged. Every time it's waterlogged, and the farmer in Egypt, okay, just put the water, and we have tubes, and make ultrasonic sensors and make the experiment for this one to reduce which level of water can make automatic controls to make irrigated for the rice. This is very benefit for also methane gases emissions, to reduce the methane gases emissions and reduce the water for the rice and increase the yield. This is an experiment put in lysimeters in Rice Research Institute in Kafrishir. This is a cooperation with 3 organizations, Rice Research Institute, and the NAS, and Electronic Research Institute. This is and make replications for what is the level of water can make fully automated and make irrigated, and this is a different replication for the experiment. And we work into 300 Sakha, the type 300, and 108. This is rice types. We work in Sakha sessions. And this is a system. Also, we have the equipment or proximal sensors for remote sensing to see what is the rice crops have stress or not. We collect the data from the remote sensing data and the maintenance, and this is a teamwork. This is the system. And how to collect with the thermal camera, chlorophyll content, leaf area index, and the spectroscopic techniques to collect the spectra, and to just make a communication with the satellite data, and you see what is the stress of the planet and what is a correlation with the yield, etc. After that, we make implementation in the open field. The system, make also it's an open field. This is how to implement. Dr. Abduraouf, my colleague, is here, and Dr. Mohammed Al-Roum, who will implement the system in the open field in Sakha research stations, implement the system in the open field to test what is the system is okay or not. Because
Dr. Time?
okay. This is the system, and this also calculates the water to calculate the water productivity, how water productivity is, and this is the system, this is the final one system. Okay, we start. And also make harvesting, make correlation with the yield. This is very important thing for us, the yield. In the end, okay, we develop this system, but what is the relation between the yield? This is also how to harvest in Sakha research stations. Next, please. This is the data that collects the data. This is the data on cloud-based and mobile application. Next. What is the future of this one? We have modern irrigation systems in North governorates, Kafr Sheikh, the Ghanaya, the Bahira, and you can put the sensors in the fields, and you can in the valve, put other sensors in the valve, and make fully controlled systems. And this is a system. If we need to do this system commercial, we need to cooperate with the Ministry of Irrigation, Ministry of Agriculture, and the Ministry of Research and Scientific Research to produce this one. I think these systems can benefit for Ministry of Irrigation and Ministry of Agriculture. So the farmer cannot build these systems. Now we have discussion with EOI organization, Arab Organization for Industrialization, to make a commercial one. But now we need to have how is the end user of this one. We discussed the end user is Ministry of Irrigation or Ministry of Agriculture. We need to see how to implement it. Because that's use smart technology in agriculture management project to adapt climate change, reduce water use for rice, and also establish special information databases for agriculture management resources, generalization the use of automated system in agriculture operations to ensure that continue production in time and disaster and to ensure the stability of the resource. Thanks. Thank you.
Thank you so much, Dr. Abdulaziz. It's really interesting and impressive to see the new technologies are applied on the ground, and we look forward to see them disseminated between the farmers and distributed in all over the country to make it the routine work of the routine way of the irrigation of crops, which utilize a large amount of water like rice and others. Thank you, Dr. Abdulaziz Rilem. Our next speaker now is Professor Dr. Abul Khair Badawi Sayyid. Dr. Abul Khair is a former head of fertilization technology, department head of Algae Biotechnology Unit in Agriculture and Biological Research Institute, National Research Center, NRC. Dr. Abu Khair has got his bachelor degree in plant biochemistry from Cairo University in 1983, and he's got his master's degree in plant physiology from Zagazig University, Manha branch in Egypt in 1995, and he got his PhD in plant physiology from Cairo University in Egypt. Dr. Abu Khair has background and experience in leaf protein isolation and identification, plant analysis and soil testing, water analysis, mass production of microalgae, algae growth unit designing and developing, and also production cost minimization for the production of algae secondary products. He has got also experience in isolation and scaling up of local and foreign algae strains, pigment production and isolation, algae oil isolation and biodiesel formation, also industrial and drainage water treatment, and formulation of mineral and organic fertilizers. Dr. Abu Khair also is affiliated with the Egyptian Society of Psychology, and the ArabNet of Plant Nutrition, and the Egyptian Society of Plant Nutrition and Fertilization. Dr. Abu Khair is a supervisor for more than 50 master's and PhD theses in pharmacology, veterinary sciences, agriculture engineering, agriculture biotechnology, environmental fisheries, home economics, urban and regional planning, and applied arts. Welcome, Dr. Abu Khair, and the floor is yours. Fadal.
السلام عليكم ورحمة الله وبركاته، كل سنة وحضراتكم طيبين، وأتقدم بالشكر لمركز بحوث المية واللجنة المنظمة على اختياري للمشاركة في الورك شوب الحالي، وأتمنى أن أحوز قدر من الثقة الثاني قدام الناس متخصصة. The current presentation talking about the maximization of wastewater treatment in specific of saline water. The main item of the title on closed chain protocol, complete water scarcity, aiming at the reutilizing of saline water or different wastewater using two main systems. The first system is to use direct algae for wastewater treatment, while the second is to use the products from algae to overcome the adverse effect of salinity effect. As you know, wastewater treatment, there is an old technique or ordinary technique for wastewater treatment, but there is one very old system from the Second World War, put it out, confirmed by Oswald, is to use algae for oxidation bond activation to utilize or wastewater treatment. What is algae, or what are algae, or why algae? The two questions is meaning one question. Algae are a simplified microorganism belonging to plant kingdom, divided as non-higher plants. But actually, algae are the most smart microorganism on the earth. It could be grown under all ambient or given conditions, ranging from fresh water to brackish water to saline water or hypersaline water. In addition, algae able to utilize and absorb all nutrients given from different sources, except some nutrients as we see before. To grow algae, ranging from unicell to macroalgae, and the selection of specific strains or species is defined by why this strain will be used for wastewater or brackish water, and why this algae will select to produce certain compounds. A natural habitat from fresh to brackish to saline to more saline or hypersaline, since some algae species able to grow big 40 grams per liter of salts. At this moment, they can survive their life but not productive. In Egypt, we successfully produce some algae at 95 grams per liter of salts. For algae production or for algae growth, like any higher plants, they require macro and micronutrients with small amounts of certain nutrients. The main required minerals or metals is carbon, which reach about 50% of algal cell composition. As for macronutrients, nitrogen, phosphorus, potassium, calcium, sodium, magnesium, micronutrients, iron, zinc, manganese, copper. For trace element, we need boron, molybdenum, cobalt, nickel, vanadium, silicon. In the laboratory, we use all of these minerals to form the suitable nutrient solution for algae. But in mass production in Egypt or in place all over the world, we prefer to use groundwater or saline water to grow algae, because this water contains a high quantity of nutrients which will be used by algae and save the production cost. The different host water types we need with algae, as you see, mainly agricultural wastes and food industrial waste. There is a lot of wastewater types, but chemicals not allowed to grow with algae, but the main from food industry and agricultural process. Now, try to make or grow or scaling up the algae production in Egypt. Historically, algae in Egypt was started by the middle of 1935 in the RC, aiming at the production of new source of protein. But we change our aim to produce another things, mainly production of algae to use it for saline water irrigation. In Egypt, it was started by foreign strains from algae and exposed heavy, high failure of growth, so we try to isolate from local habitat and defined by different Egyptian sites. We scaling up the volume of cultivation till to 200 liter, then open pond up to 45 cubic meter with tubular photoreactor or open pond, and then after collected it by centrifugation. What is our hypothesis in algae production and saline water irrigation? As I said before, to grow algae, we need macro and micronutrients. Saline water or brackish water or industrial or wastes from industrial food industries water, wastewater contain a huge amount of nutrients, especially carbon. But in some cases, algae not able to utilize phosphorus or algae not able to utilize organic phosphorus, but only utilize orthophosphate. So we need to manipulate some microorganisms to liberate mineralized phosphorus from organic phosphorus. The main hypothesis is referring to magnetic water depending on the cleavage of sodium and chloride bond. And after some time, and after certain times, rebending again based on the power of magnetic field and the electricity and the length of application process. When we use arch for biological treatment, we can see that this system was applied in Egypt since 15 years. This open pond for water storage in farms or for fish production. We put arch with fish and already found microorganisms, bacteria. When fish growth is accompanied by a huge amount of waste, this was fermented by bacteria to produce ammonia and other organic nitrogen compounds. At this moment, this bacteria required oxygen, and the fish also required oxygen. The competition between bacteria and fish towards bacteria because they have a longer surface area rather than fish. When we put bacterium fermentation in addition to producing nitrogen compounds and organic compounds, rising the pH and reducing the oxygen, which in turn led to fish die. The presence of algae are able to consume all concentrations and forms of nitrogen, producing the oxygen. Oxygen will be used for fish growth and bacteria. This is a submerged pump we use to irrigation. In other case, we use this water for aquaponics cultivation, and in some cases when nitrate amount or ammonia amount increase, it will damage some plants in hydroponic. So we return this water again for direct irrigation or to this point. This system was applied since 15 years ago, increasing the productivity and the income with the private sector up to 20%. This is the sum of plants grown under treated soil water. On the other hand, what is the goal of algae production? At first, we treat water to save fish production and increase the water loss from organic matters and nutrients.
Doctor, time please.
Here,
2 minutes.
Here, if one faddan of algae produce biostimulator able to reclaim or fertilize about 500 faddan organic cultivation. However, if we use it for inorganic cultivation, this value will rise it to about 60,000 faddan. the last is to use algae in treatment of hypersaline water. The upper photo from water, drinking water, which reach about 400 grams per liter of nutrients at first. At first, we remove the color and the odor, and then react with with chemicals to collect the precipitate and soil. On the other hand, for salt production company, we were producing huge amount of water, reached more than 500 grams per liter. We use this water by chemical precipitation after isolation of sodium chloride and the sodium bisulfate and sodium sulfate anhydrous. We will use three types of minerals. In conclusion, wastewater after physical treatment, we enter the chemical treatment, physical chemical treatment, chemical treatment reducing the byproducts, mainly salts, and then after algae growth, reducing algal biomass. This is more added value than any other water than salts, and at least saline water using in cultivation of some crops. This water, the produced water, was treated and tested with different amount of different numbers of plants. Okay.
Thank you so much, Dr. Abu Khair Badawi. Thank you so much for your informative presentation. I think we'll keep the questions to the end of this session. Now I will ask Dr. Abdelhamid Khater to introduce the next speaker, who is Dr. Mohammed Said, our colleague at the Agriculture Research Center.
Good afternoon. Our next speaker is Professor Mohammed Said from Agriculture Research Institute, from the Soil, Water, Environmental Research Institute. Dr. Mohammed Said is a chief researcher and the director of the technical office of Soil, Water, and Environmental Research Institute, Agriculture Research Center in Egypt. He is a member in American Chemical Society, and he is a member of Egyptian National Committee of Soil Sciences. Dr. Mohammed earned his PhD in chemistry from Sohag University in Egypt in 2013. In the same year, he received the annual prize award from the best published article in Swahili. He received a Fulbright postdoctoral scholarship in 2014 with South Dakota University, USA. He also got the certificate of merit from the American Chemical Society Division of Environmental Chemistry for his presentation at 249th in the national meeting in Geneva. He is the principal nominee for the Fulbright Alumni Activity Egypt Food Security Research Project in 2019-2021. In 2020, he received a certificate of second rank award from the International Wave Conference Perspective on Agriculture and Applied Science in the COVID-19 scenario for his oral presentation in October 4th, 2020. He was awarded Distinguished Scientist Award 2021 from Agriculture and Environmental Technology Development Society. Dr. Mohammed is a team lead for different projects such as effectiveness of irrigation practices and nano biochar on water productivity under saline condition with ICARDA in 2023-2026. The second project is the joint cooperation for applied research program Jakar, Egypt, in cooperation with the Netherlands, and the third is water productivity through open access remotely sensed derived data, WEBOR, in cooperation with PAO, as well as Dr. Said is a focal point for different projects like MENA MENA national focal point for the UN Decade ecosystem restoration. And lastly, the project in cooperation with International Water Management Institute by support of the British Foreign Development Office. Dr. Saiti is the author of numerous international publications, including high-impact research papers, 40 papers, and book chapters. He was a co-convener of accreditation at the 16th International Clay Conference called Environmental Application of Clay Minerals. He presently serves as an editor for advancements in Material Journal and the International Journal of Environmental Chemistry, as well as a reviewer for a number of journals. Dr. Muhammad, the floor is yours.
شكرا دكتور حميد. بسم الله الرحمن الرحيم، والصلاه والسلام على اشرف المرسلين سيدنا محمد على اله وصحبه وسلم. احب اشكر طبعا المركز القومي لحرس الميه والتشريف على الدعوه الكريمه ان انا انضم لكم النهارده في ورشه العمل. احب اشكر برضه الفام والايكاردا على تعاونهم. واحنا I will start my presentation is related to successful implementation of the rationalization of the irrigation water in Egypt. In the beginning, I will follow up my colleagues that told about the water shortage in Egypt and increasing the population, as well as the increasing agriculture and industrial development, as well as the climate change impact on the water sector in Egypt and how it's shortage, and what we think is very important to us, because about 80% of the water that we water sources that we use in agriculture, especially in low income country and middle income countries. So water management is very important task we need to deal with, and looking for conventional or non-conventional water sources is very important for us. So we're looking for different mechanisms, like water management by using agricultural practices, for example, like a cultivation method, like raised bed methods in cultivation, as well as how to use some techniques or some ways to using some crops that allow short life crops and something like that, and transformation from the surface irrigation to modern irrigation system like drip irrigation or sprinkler. We will summarizing 3 projects that we already involved in. One of is called Jakar, is related to the cooperation between Egypt and Netherlands, and the second one is a cooperation with FAO, is related to rationalizing using water in cultivation rice. And the third one is related to cooperation with ICARDA, and is how using soil amendment to adapt with low quality water and how enhancing the water productivity. Here, with Jakar, the main issue in what we're thinking in Jakar project, that how to modernization or transformation from the surface irrigation to drip irrigation, and how to cope with increasing the salinity, especially in the north of Delta. To study our pilot area, we're focusing on the north of Delta and buffer state area. And we tested 2 pilot areas. One pilot is comparing between the surface and drip irrigation in the north of Delta, and it's a very important point, and we will thinking about what increasing the salinity in the soil and how we adapt with this. And the second point with dealing with saline soil, saline water, how we can deal and management with this and increasing the productivity. As for the first location, we have the fresh water there, and the saline soil is very low, and we applied transformation from surface to drip irrigation with 3 crops: maize in summer, wheat in winter, and watermelon in the summer. And nowadays we cultivate sugar beet. We have a very important result. We have increasing in the yield under drip irrigation, and in 3 seasons, and sorry, the increasing between 30 to 40% for productivity, and this is very important. The second one, increasing the water saving. We save about from 20 to 25% of the water that we use under the drip irrigation. It's very important issue what we suffering in this location, the salinity built up the soil. We focusing on in this point, and we noted that during the season by season we have increasing in the soil salinity, and this is very important top point. We thinking about the strategy to adapt with this increasing in the soil salinity built up, and we thinking about how we can deal between the 2 seasons, first season and second season. We push a flush irrigation 1 point for flushing or reaching the salinity built up between the between first season and second season, and between second season and third season, as well as between the third season and fourth season. And after that, we find that still we have soil salinity built up. So we thinking about the strategy to adapt with this with cultivation rise in the fifth season, and it's very important to reducing the salinity built up. The business case explains very important point for the farmers, because the farmers looking for his benefits and how he can gain more money, and under drip irrigation will have very high net farmer income, and this is very important for him. But we're still thinking about the salinity built up in this area. The second location is how to adapt with the soil salinity and how we adapt with saline water. In this location, we have saline water, saline soil, and we using it for treatment process. One is mold drain, and the second is leaching requirement and gypsum requirement, the third one. And the fourth one is how to integrate between the 3 treatments together to enhance and reduce the soil salinity. The results during the 3 previous seasons with maize, wheat, and watermelon, we noted that with during under the gypsum requirement, leaching requirement, and mold drain, we have a very important result, and we're reducing the soil salinity by 40%. It's a very important point to reducing the soil salinity. And this is, I will take directly to this point. Is very important because we, according to our result and according to reducing in the soil salinity, we have increasing in the production and increasing in productivity, water productivity as well. So during the season of the maize, we are reducing the soil salinity and then enhancing the productivity as well with wheat, as well with watermelon. This means that by decreasing the soil salinity and with under our treatment, we have increasing in productivity and water productivity especially. And the business case as well represented this in net income for the farmer start to be more and more during the increasing the productivity. We're facing some problem with the farmers because we need to increase awareness between the farmers and how we deal with the soil salinity and how we deal with the modernization, for example, and the process. And we are making 2 or 3 field days to support our vision, our results to the farmers. What we should need to concern, okay. We try to understand and to looking for the good strategy to adapt with the transformation from the surface to drip irrigation in the coffee shade, especially under the salinity and salinity stress, and looking for the methodology to adapt with soil salinity, and what more than 2 or 3 strategies to adapt with the irrigation. I will move to another project in cooperation with FAO, is related to the pilot water saving irrigation technique. In this project, it's very easy. Just we use the cultivation method only in cultivate the rice. I will move to the process. we chose 4 pilot area there. And I need to just, this is the tractor, and we adopt the tractor to be in this is the slice, it's 45, like the raised bed, like we cultivate here in this area. This one for the crops and the second crops here, and to be like this. So just we apply this technique in cultivation rice, and we noted that here, if you're looking directly to the field, we looking that you just irrigate 40% from the field. This means that you saving a lot of water regarding this point. By comparison between our idea in cultivation and with traditional one, we can imagine that we can save more and more water during this process.
GPS signal lost.
Okay, this is a comparison between our Bible and traditional one. I will move back to the beneficial. We saving through the first pilot, we saving about 27% of the water, and the second is 19, and the third one is 33% from the water that we saving. And the yield, we start increasing the yield between our pilot area to be more than 1 ton per feather. The main advantage that we not need to infrastructure, we need to more money, just making this method for cultivation, and we will enhance our activity and water saving between 20 to 30, saving fertilizers as well as saving power, because we not need to add more water. But we're thinking again how we can increasing the awareness between the farmers related to this method in cultivation, and how we can move into another government like cover shape, Behera, and another government. The third one that I will need to talk about is related to enhancing water productivity in some crops under the low quality water. Okay. If we're using saline water in irrigation, we need to adapt with this water, and maybe we can do that by using soil amendment or leaching, or using some irrigation techniques, or desalination for the water. What we need here, what we're thinking, how we can use the soil amendment like biochar and nanobiochar to adapt with the saline water as well under the drip irrigation system. The research project is focusing on the water productivity and the soil performance, how it enhance under the using the saline water, and how using the biochar and the nanobiochar under 2 types of soil, clay and sandy soil. We already done this in rice meters, and using water with the saline water is 4,000 ppm, and using the same rate for addition of nanobiochar and biochar to 200 kilogram per feather, and this is to consider that less than 10 times than the recommended dose of addition of biochar. This is some results for biochar and nanobiochar, and how we have the high BET surface area and composition of the carbon and oxygen. And this is a scanning microscope for the biochar. We applied preparation nanobiochar by using physical methods, and so the particles is still be distributed a little bit, but we in the same size of the nano. We applied this water in the soybean and in wheat. The nanobiochar reducing the amount of water that we use, and we have more in increasing in the yield under the clay soil and sand soil. The same behavior with wheat. Okay, The soil products, we have enhancing the soil organic matter, improving nutrient retention, enhancing soil quality under using the nanobiochar. And what we think in the future, how to upscaling this idea and how we adopt with the saline water using the nanobiochar and under the drip irrigation or modern irrigation system. Thank you and welcome for the questions.
Thank you, Dr. Mohammed. Now we can start the discussion for our three speakers, Dr. Abdelaziz Bilal and Dr. Khalid Badawi and Dr. Mohammed Al-Said. Any questions? We can start here. اتفضل. لو ممكن حضرتك عرف نفسك الاول وممكن نتكلم عربي مفيش مشكله. انا شايفه مفيش اجانب معانا دلوقتي.
مفيش. كل عام وحضراتكم طيبين. انا حبيت اشكر كل اللي هم عرضوا، انما انا ليا سؤال او استيضاح من الدكتور عبد العزيز بلال بخصوص ان هو عمل الويت اند دراي irrigation الرايز. انا بس عايز اساله، هم حاجتين هنستخدم فيهم المجسات او السنسور لاستخدام التجربه دي. اللي انا شفته هو استخدم السويل سنسور وهيظبط هو على مثلا الدراي عشان يبتدي يشتغل بيها وكان يفتح اون اند اوف ذا فارم. هل في هناك كان اشتراك من معهد المحاصيل للدكتور حمدي على الرز ولا لا؟ وهل في نتائج حضراتكم طلعتوها في مساحات اكبر من المساحات اللي احنا شفناها تحت جرين هاوس او تحت النت؟ شكرا.
دكتور عبد العزيز يحب نعلق على السؤال؟
مش موجود.
Next question. اتفضل.
بسم الله الرحمن الرحيم. شكرا. بس اسال الدكتور ابو الخير بالنسبه لشغل الطحالب. الطحالب احنا عارفين عندنا اللون الاخير، اللون الطحالب الزرقاء والطحالب الخضراء. هل البيهيفير بتاع نفس الاثنين بيبقى موجود بيبقى هو واحد؟ وهل بيبقوا ناس تحت الاعماق بتاعت الميه؟ يعني في عمق سطحي في طحالب سطحي وطحالب تحت سطحي. ولو سبت يبقى في جزء منها هنا وجزء من هنا. دي حاجه، ده سؤال. السؤال الثاني بالنسبه حضرتك
هرد على ده. السؤال ده لوحده 3 قطع. هرد عليه قطعه قطعه.
لا اتفضل.
اتفضل سعادتك.
فالسؤال بتاع حضرتك الاول ان الطحالب اخضر وازرق. هو الحقيقه ان هي اكثر من 9 الوان او 9 طوائف، اخضر وازرق. مفيش ازرق بالمعنى المعروف، هي بلو جرين اورج اللي هي الطحالب الخضراء او الاخضر والاحمر وحاجه اسمها البني، وبعد كده الدياتومات واليوبلينات حاجات بعيده قوي. بس اللي هو الحاجه اللي بنفسها قوي الاخضر والبلو جرين والاحمر والبني والتاني. شوف التاني بقى حضرتك السؤال التاني.
هل السلوك بتاعهم كلهم متساوي؟ السلوك بتاعهم واحد؟
الايه؟
السلوك بتاعهم
السلوك بتاعهم. انا بس ما جاليش فرصه ان انا اتكلم بالتفصيل، يعني ان انا بتكلم على لو عندي طحالب وحيده الخليه تبع الكلوريفايتر اللي هي الطحالب الخضراء. الطحالب وحيده الخليه دي تقدر تعيش في الميه العذبه وتقدر تعيش في الميه البارده وتقدر تعيش في الميه المالحه. هنا نوع وهنا نوع وهنا نوع. يعني عندي الكلوريد يعيش في الميه العذبه، الناريل يعيش في الميه المالحه اللي هي لحد 85 جرام في اللتر. يبقى هنا السلوك واقف على النشر الهابيتات بتاعها والكونديشنز اللي هي عايشه فيها. يعني ممكن اربي الكلوريد او السبالويدا في مكان واحد طالما الظروف البيئيه مناسبه لكل واحد، ما لهمش ظروف بيئيه واحده، طالما كل واحد له ظروف البيئيه النمو هو الهدف. ده من ناحيه السلوك. يبقى السلوك يعتمد على الحاله الغذائيه والظروف البيئيه.
الاعماق بتاعت الميه، لو انا ميه في ترعه وغير ميه في مصر. في مصر بيبقى
الطحالب بطبيعتها 99% منها نون موتيل غير متحرك. فلو ما كانش فيه تقليب ميه كل الطحالب بتربط في الارض وتتحول الى ماده عضويه وبتوصل لمرحله التخامر والتعفن. ولكن في احواض السمك الحركه تحت السمك والطيب بتاع الهواء بيسمح ان هي الرسوب بتاعها يكون اقل شويه.
اي اسئله ثانيه؟ دكتور محمد نقول.
السلام عليكم دكتور ابو الخير، معلش هنوقف حضرتك تاني. بقول لحضرتك محمد الخوري مدير معهد بحوث الاراضي والمياه والبيئه. بسال حضرتك الريتنشن تايم بتاع المعالجه كان خاصه بالالجي اللي حضرتك بتستخدمها كام ساعه؟ تمام؟ وحضرتك هل حضرتك عملتها على لارج سكيل او عملت لها سكيل اب للنموذج اللي حضرتك عملته؟ اكبر نموذج عملته ايه؟
اكبر نموذج
في المعالجه. معلش حاجه ثانيه، حضرتك دي تعتبر بتحط الالجي بعد البرايمري تريتمنتس ولا حضرتك بتعتبرها هي من الاصل ممكن تستخدمها على طول من الرول بتاعت الويست ووتر تريتمنتس تحط الالجي على طول، ولا دي تعتبر بتستخدمها برايمري تريتمنتس او سكندري او ممكن تبقى تيرشري تريتمنتس ديبيندز على الستيشنز اللي حضرتك بتستخدمها؟
اول سؤال كان الريتنشن تايم.
الاول خالص الريتنشن تايم دوت بيتوقف على نوع الميه اللي انا هتعامل عليه. لو انا بشتغل على الريتنشن تايم لميه مالحه هستخدم الميه المالحه دي بالزراعه، بس مش ميه مالحه يعني اقصى رقم اشتغلنا عليه في الري 10,000 جزء في المليون وجاب نتائج ناجحه على الساليفورنيا وعلى الكلام. هنا الريتنشن تايم ما بيقلش عن 24 ساعه، بربط الطحالب في الميه اللي هروي بيها لمده 24 ساعه وبعد كده بروي بالميه الكونتينيو ارش. جربنا ان احنا نروي بالميه بعد فصل الطحالب وجربنا ان احنا نروي بالطحالب الووتر كونتينيو لايف ارش. طبعا النتائج جت لصالح ووتر كونتينيو لايف ارش. ده الجزء الاول. الجزء الثاني حضرتك فكرني بيه. السكيل معالجه ولا انتاج طحالب؟
لا حضرتك انا بتكلم معالجه.
المعالجه. بسم الله الرحمن الرحيم. المعالجه بتبقى المزارع الخاصه عاده بيبقى الاحواض بتاع تخزين الميه من 20 طول عرض في 50 طول.
كم متر مكعب؟
في عمق احنا بنفضل ان يكون العمق 6 متر. لو 20 في 50 في 6 ب 6000 متر مكعب. 6000 متر مكعب. وفي اماكن يعني احنا في اماكن اوريدي موجوده جهات حكوميه يعني بنطبق فيها الكلام ده. فاكبر حجم اشتغلناه 6000 متر مكعب. ال 6000 متر مكعب دول لما نيجي نطبقهم انت للري ولا للمعالجه؟ لو للمعالجه الريتنشن تايم هنا هيكون من 48 ل 72 ساعه. لو للزراعه هم 24 ساعه في الميه المالحه.
وايه الفرق بين المعالجه والزراعه؟ اصل انا عندي معالجه حاجتين، يا اما انت هتعمل ديسبوزل للميه دي في الووتر ستريمز يا اما هتستخدمها في الاجريكلتشر.
لا انا اتكلمت على نوعين من الميه.
ايوه فاهم.
الميه المالحه الريتنشن تايم بتاعها انا معاك يعني. الميه المالحه الريتنشن تايم بتاعها 24 ساعه عشان اخدها اروي بيها. ودي نقطه من اول السطر. لكن الميه السويج اللي هي بعد المعالجه الثلاثيه دي انا هربي فيها الريتنشن تايم هيبقى من 48 ل 72 ساعه. اللي اضمن بيها ان انا شلت كل الهيفي ميتالز وشلت وقضيت على اكثر من 90% من الباثوجين. كمل اسال حضرتك.
لا تمام، بس انا بتكلم عشان انا اعمل، طبعا هو فكره كويسه جدا وتجربه كويسه، لكن انا كمحتاج ان الريتنشن تايم ما يزيدش عن 6 ساعات.
ما هو
ليه؟
كان الوقت يسمح احنا المطلوب ان احنا نعدل بعد كده في عمليه الباسنج بتاع الميه. انا ما عنديش مساحه من الارض ان انا اخزن كميات الميه اللي بتجيلي كل شويه.
بالظبط، عشان كده انا ببص دايما الفكره البحوث ازاي تبقى على مستوى اللي انا اقدر اعمل لها ابلكيشن. فطبعا دي كويسه جدا حضرتك تعملها على نطاق مزرعه، لكن انا ما اقدرش اخدها مثلا في استراتيجيه بتاع الدوله مثلا في عمليه المعالجه.
لا هي لو ارض جديده
ده ولا ارض جديده.
لا لو مجتمع جديد ممكن، انا اسف، لو مجتمع جديد الوسط اللي جايه منه قليله وهعمل حساباتي على كده ممكن قوي. في حاجه ثانيه احنا لسه ما عملناهاش بس دي انا ببقى ضدها شويه، ان انا استخدم الميه دي شويه كده على الويت لاند وبعد كده يعني ازاي عندي اوديها على الويت لاند. وده برضه معمول في اماكن في مصر يعني حاجات خاصه بالناس هم حاطين فيها، بس اللي احنا نجحنا فيه قوي وحطينا ايدينا عليه قوي الميه المالحه بتاعت تكرير البترول والميه المالحه بتاع مصانع انتاج الملح، والمشكله بتاعت انتاج الاسماك، لان فدان السمك بيخسر كل سنه 25,000 متر مكعب ميه، ده بيترمي، وبشغل مكنه الري 52 يوم في السنه لمده 24 ساعه في اليوم مع عماله 52 يوم مع استهلاك طاقه 52 يوم.
شكرا دكتوره وكيل. اي اسئله ثانيه؟ طيب ناخد هناك
محمد شعبان.
يعني هو لسه في وقت على الفطار طبعا، فاحنا قاعدين مع بعض، لو في اي مناقشات ثانيه ممكن نكملها بعد السيشن ان شاء الله. اتفضل يا دكتور.
بسم الله الرحمن الرحيم. محمد شعبان مع الصدر مركز القومي للبروسيديا. انا عندي سؤال بقى للدكتور عبد العزيز بلال والدكتور محمد سيد. انا عارف الدكتور عبد العزيز مش موجود، فانا اتعشى من الدكتور محمد سيد يجاوب لي. هما الاثنين في نفس الموضوع. هو الدكتور عبد العزيز والدكتور محمد الاثنين اتكلموا على تقنيات تحسين كفاءة مياه الري. والاثنين قالوا في التو برزنتيشنز بتاعتهم انه يعني الدكتور بلال قال انه حصل تحسن في الووتر سيفنج من 30 ل 35%. حضرتك قلت نفس الكلام يا دكتور محمد مش كده؟ انا بس عاوز اعرف هو البيز لاين اللي اتحسب عليه التحسن ده كام؟ يعني هي كانت كام وبقت كام؟ يعني انا المفروض انا فاهمي لتحسين الكفاءه لما اقول النظام الري الفلاني حسن الكفاءه 30%، فانا ما تجيش مثلا بالنظام ري كفاءته لو هو حتى ري بالغمر. الكتب بتقول ان كفاءه الري بالغمر 60%، لكن احنا عارفين ان الابلكيشنز اللي موجوده ممكن تبقى 30 و40 و25%. فانا ابتديت الحسبه بتاعت ال 30% دول جايين من ال 25 ولا جايين من 60؟ هو ده السؤال الاولاني. السؤال الثاني لانه لو انا بسال ليه؟ لو انا اتحركت من ال 25 ورفعتها لل 60، طب ما انا كنت احسن الري بالغمر بقى وخليني في اللي انا فيه من غير ما اعمل التكاليف انا مش ضد التطور، بس انا عاوز افهم. انا الصوره مش واضحه بالنسبه لي. البيز لاين اللي اتحركت عليه من القيمه انا حسبت 35% من فين. النقطه الثانيه برضو ما حدش قال لنا التكاليف. يمكن الدكتور محمد يعني ما كانش المشكله عنده اكتر، لكن المشكله الاولانيه في الشغل بتاع الدكتور بلال لو حد عنده اجابه يقول لنا. هو قال ان انا كسبت ريفينيو، كسبت انكم، الانتاجيه بتاعت المحصول زادت. طب ما قاليش قد ايه انا كسبت فلوس، لان انا صرفت فلوس كتير جدا على الانفراستراكشر والتكنولوجي والتريننج والسنسورز تاني. ارجو الا يفهم ان انا ضد ان احنا نشتغل تطور، بس انا عشان اقدر اقيم الموضوع لازم اقيمه بشكل جيد. برضه من ضمن الحاجات.
نجاوب على الاسئله الاول يا دكتور؟
لا ما لسه سؤال واحد وهمشي خلاص. احنا كل ده يرتبط بالاحتياج المائي. انا عاوز اعرف الاحتياج المائي وبالتالي اقدر اقول الكفاءه اتحسنت ولا لا. فانا حاسس كده ان احنا بنقول ان احنا حسنا وبعدين بنلاقي مشكله ملوحه، فبنبتدي نتعامل مع الملوحه دي ونحسن ونعمل ليتشنج ريكوايرمنتس والكلام ده. فانا عايز انا بتصور ان الليتشنج ريكوايرمنت هي جزء اساسي من الاحتياج المائي. فما ينفعش احسب الاول الكفاءه وبعدين اقول والله ده انا محتاج شويه ميه احسن بيهم وخصوصا في الارض زي منطقه كفر الشيخ. لو انا فاكر كويس يا دكتور، المشكله هنا في الغالب مش هتبقى تملح ارض نتيجه انه في املاح في التربه، ده نتيجه في الغالب جزء هيبقى سي ووتر ديفروجن، فده الملح ده مستمر معاه على طول. يعني لن يحدث انه الملح السنه دي كان اكس، السنه اللي جايه هيبقى ماينس وهكذا، مش هيحصل. لا، هتفضل الاملاح دي معايا. وبالتالي الاحتياج المائي هنا لازم يشمل الحاجه اللي انا ما فهمتهاش هو البايو. ايه اللي بيعمله البايو شار او النانو؟ انا معلش سامحني، انا اصلا صرف يعني، فانا مش فاهم بالظبط البايو شار ده هيعمل ايه في حسن لي الكفاءه ازاي. شكرا يا فندم واسف للطلب.
دكتور محمد قدامك دقيقتين جاوب على كل الاسئله.
ابدا يعني مش عارف ابدا من الاول. الميه احنا ديبين طبعا في عندنا الووتر ريكوايرمنت ودي من الاساس اللي عندي. دي انا بحسب بيها وبحسب نظام الكروب وات ويبقى عندي رقم وبشوف انا ابلايد كام في المية من الميه وده الاختصار اللي عندي. يعني بدات ب5.5 في الرز ووصلت لحد 3800 انا وفرت من 20 ل 30% نسبه ميه دي في الاضافه. دي طريقه سهله للحساب يعني. من 5.5 وصلت من الاحتياج المائي. الاحتياج المائي الووتر ريكوايرمنت الرز اللي احنا زرعناه في كفر الشيخ 5.5 متر مكعب 5500 متر مكعب.
لا الاحتياج المائي لو انا فاهمه صح اللي هو الايفابو ترانسبيريشن مضروب في الكيس ده اللي هو الايفابو ترانسبيريشن بتاع المحصول. لكن الاحتياج بيبقى فيه كفاءه بعد كده وبيبقى فيه الاحتياج
كل طرق الري بيبقى فيها محسوب لها الليتشنج ريكوايرمنت بتاعتها. يعني حتى احنا لما بنستخدم يعني معنى المثال البسيط يعني الدريب irrigation هو احنا بندي الووتر ريكوايرمنت 100% هو كفاءته 85 فانا عندي 15% اوريدي موجوده مع الدريب irrigation هي الليتشنج يعني موجوده كنسبه فراكشنز موجود عندي في حساباتي موجود. يعني انا عامل حسابي واحد حساباتي في الليتشنج ريكوايرمنت ده موجوده في كل طريقه انا بستخدمها وبتتحسب على حسب ملوحه التربه. يعني انا برضه في الاخر الليتشنج ريكوايرمنت اللي عندي انا بحسبه بناء على السويل سالينيتي والووتر سالينيتي. تمام؟ دي في الجزء الاولاني انا قلت وفرت ازاي الميه. الجزء الثاني بتاع النانو باتشار والباتشار الباتشار ده سويل امينمنت هو اساسا جاي من المخلفات الزراعيه. احنا بنعمل لها حرق في معزله عن الهواء فبيحصل لها مش حرق بيحصل لها تحلل وبيبقى فيها لسه ستيل موجوده الفانكشن جروب. لما بنضيف على السويل بتبقى فيها فانكشن جروب ترتبط مع العناصر مع بعضها وتدي كفاءه وتحسين باختصاص التربه وعندها قدره تزود قيمه السي بتاعتها. الفكره كلها قلنا ان لما بتضيف تركيزات كتير من الباتشار بيبقى الباتشار ساعات كتير بيبقى البيئه اشتكوا عليه دي كانت نيجاتيف امباكت عليه. فلما بنقلله لنسبه النانو بنستخدم عشر الكميه المضافه فبالتالي احنا ما زودناش السويل بي اتش ودي مهمه بالنسبه لنا لان السويل بي اتش بتاعتنا عاليه. فانا ضفت حوالي حتى انا كنت مركز قوي على التركيز احنا ضفنا 200 كيلو جرام للفدان ده المعدل اللي احنا ضفنا بيه مع انه الطبيعي للبشار الطبيعي 2 طن الى 4 طن للاضافه للفدان. فانا استخدمت عشر الكميه والحمد لله ادتني انتاجيه اعلى وادتني اضفت مع السلايم.
هل بيأثر على الاحتياج المائي؟ هل بيأثر على كميه الميه؟
هو قلل كميه الميه لازم لازم واحنا بنربطها بحنفيه بكميه ميه محدوده بتضاف لها بنحسبها بالظبط. فاحنا حسبنا وحتى كان جدول كان متضاف كان في الووتر ريكوايرمنت او كميه الميه اللي استخدمت لكل بلوت عندي كل لازم لوحده منفصل بيتحسب وبنحسب منها الانتاجيه والانتاجيه المائيه.
هل السبب في توفير الميه هنا هي زياده قدره التربه على الاحتفاظ بالمياه؟
لان هو كسويل لما زي الماده العضويه بس هي ميزتها ان هي مور ستيبل في التربه اكتر.
شكرا دكتور محمد. هنخلي بقيه المناقشات في الاخر خالص ويعني بشكر الثري سبيكرز اللي كانوا معانا في هذا السيشن الدكتور عبد العزيز بلال الدكتور ابو الخير بدوي والدكتور محمد السيد. شكرا جزيلا لحضرتك.
شكرا جزيلا دكتوره شيرين عاصم moderating the session. شكرا دكتور عبد الحميد for moderating. احنا دلوقتي عندنا break for 5 minutes please. هنرجع الساعه 3. انا عارفه ان البريك كانت المفروض تبقى اكتر من كده بس نحاول stick to the time عشان احنا committed بالفطار في الاخر. فنراكم بعد 5 minutes.
First, as Dr. Yaman said, that the session is main theme is water use and recycling innovation, and we are meaning here water use by either the drainage, the agricultural drainage water or the waste, treated wastewater. Of course, all of us know that the use of water, either drainage or treated wastewater, for time being is not an option. It is must. All of us know that our water budget is limited and the challenges that we face protecting the water availability in Egypt here is we know all of us that the share of per capita for the Egypt here for the per capita is about 560 meter per year, which is under the poverty limit of water, which is 1,000 cubic meter per year. And also, all of us know that the Egyptian government now pump huge investment into many national mega projects in Egypt here based on use the agriculture drainage water as a main source or the main feed for it. As for example, in the summer project, Bahr al-Bar project in the eastern Nile Delta, in the eastern part of the Delta in Sinai, and of course the new Delta project in western part. For that, I'm inviting Dr. Mohammed Shaban, the director of Drainage Research Institute, to give us an idea about the challenges and opportunities of agricultural water use in Egypt. Dr. Shaban also, of course, has his PhD and master degree in water resources management and environmental engineering from Leuphana University in Germany. He has 30 years of experience in environmental research and contributed to numerous national and international collaborative projects focusing on sustainable development and the reciprocal impact of human activity on the environment. Dr. Shaban has held many positions during his career, and finally he is the director of the Drainage Research Institute, National Water Research. Dr. Shaban, the floor is yours. Go ahead.
سامعني كده؟ كويس. أنا سعيد جدا إن أنا أكون معاكم النهارده، كل سنة وحضراتكم جميعا طيبين، وأتمنى ما يعني الناس اللي أنا سألتهم ما يبصوش عليا في الأسئلة. مستنيين. مستنيين يعني. طيب. Should we talk in English? The title of my presentation today is Innovative Strategies to Increase Water Availability. My main objective is how can we see this in the future? In my point of view, the presentation objective is to show or to highlight the efforts that were done by the NWRC and Drainage Research Institute to support and to set guidelines for how to drain drainage water in agricultural drainage water, because we need to be exact. Our main task is working in the agricultural drainage water. For sure that drainage water, agricultural drainage is mixed with somehow with treated or inadequately treated, partially treated wastewater in irrigation. The content of my presentation, I will give a little introduction. We stress some points in the challenges concerning the wastewater use or agricultural drainage water use. What are the water management strategies in this concern? How can Egypt were trying to meet the challenge? And maybe we also highlight some points in some success stories, as Dr. Hussein was talking about, the 3 mega projects, plus, of course, the most important El Salam Canal project and Sheikh Jarrah. We are also coming not to talk about the previous activities, the success stories we did before, but we need to think what are still needed. How can we improve if we are very much successful? This is the final end of our progress, or there is a room that we can improve our practice. One of the topics that I would like to raise is the drainage water desalination for agriculture. And I put a question mark. Does not mean that I'm supporting or I'm against it. But we need to open the window how to think in the subject. Finally, I will present, in my point of view, some research needs that we need to work in the future in NWRC to improve the current practice. We start with the introduction. I need to give a very brief idea about the history of the Egyptian history with how to handle or how to manage water. this is the situation before the construction of High Aswan Dam. The Egyptian irrigation system was under the title inundation irrigation. In this system, when water, during the high flood season, the water in the canals is high enough, then the water, sorry, what happened? ايه اللي حصل يا بيه؟ طب انا مش انا ما بدوسش حاجه كده خلاص يا فندم. When during the high flood season, the water can enter the canal, and this area can be irrigated. But during the low flood season, the water level in the river is low, and then the canal water cannot enter the canal, and this area that is served by this canal is no longer able to irrigate. That's why, before the construction of High Aswan Dam, we were able only to cultivate one crop per year. So, one crop per year, this means almost 1/3 or 1/4 the quantity of water that is applied to our irrigation system now. After the construction of the dam, now we are able to cultivate 3 crops per year, sometimes even 4. This means the quantity of irrigation water is more applied in the ground. And we need to keep in mind that I was just doing this exercise with my colleague here. We were calculating how much salt is inside the irrigation water that is added to the Nile Delta. Very rough estimate. We assume that the irrigation salinity, the irrigation water salinity, something between 350 milligram per liter. If you take into account 14 milliard cubic meter is applied, then we are discussing 16 million tons of salt are added to the Nile Delta. Take into account 5 till 7 billion cubic meter from the drainage water we recycle, in average gives you 6 million ton. If you assume only 2 times reuse, this means 12. So in simple, without fertilizers, without pesticides, without anything, we are adding about 30 million tons salts to the Nile. So this is a challenge. We have to get rid of this salinity, otherwise the soil will be deteriorated and the agricultural practice will be eliminated. This is just to show the progress in land reclamation in Egypt. Unfortunately, I have only till 2012. If anyone has better or more recent data, I hope that this will be can be helped. But it is very clear that with time, the land reclamation in Egypt is increasing. Soil salinity is developed. Of course, most of the saline soil is in the north due to the phenomena of saltwater intrusion. But in general, if we cannot maintain the soil salinity in the Nile Delta as it is now, or of course it will be better if we improve. But at least our main target, when we apply any irrigation system, modern or super modern, we need to keep in time the salinity level. Okay, this is the challenge. We need to ensure the food security for all these people. We need to cope with water scarcity and climate change challenges. We have also problems concerning pollution and salinity. We have to take care very much with the soil salinity development with all the successive reuse of drainage water. Of course, there are many other challenges, but this is the challenges that we will work with. You can see the physical water stress in Egypt is high, in the circle, the red part. This is the water resources versus the water demand. The available water resources, as we can see here, is 59.4 billion cubic meter. We hope that this remains constant, but we have also, as all we know, the progressive increase in the population. The demand, physical demand, is 80.13 billion cubic meter, but if we add the virtual water that we are adding, then this value will increase something like 30 billion more. Then we are talking about 150. So physically, we have about more than 20 billion cubic meter deficit between supply and demand. We have also to think how complex is our system. The irrigation and drainage system is very much complicated in Egypt. We are discussing about 35,000 kilometer network for irrigation and 20,000 kilometer drainage. So when we need to think for, we need to reuse drainage water, then we need to go through all these 20,000 kilometers to check where are the most appropriate water quality that we can reuse, and also to check for where irrigation canals we can take. So it is a very important task where and when to reuse. The system to discover this is very much complicated. Of course, we did not Egypt for more than 50 years now. We are working in many different management strategies to improve these problems. I don't like to consume too much time, but we were working in both demand side and water supply. In the water supply, of course, it is very important, or it will be very important, good that you can find more resources, more conventional resources. And as you can see, at least we must secure our Nile water share, and if possible, then we can extend to new resources, which is still now very much limited. I mean, the option of increasing the supply, it sounds very limited. We need to work to improve the water governance. We need also to work, and we did, I mean, I should cancel the word we need. We did already work too much in reducing the water demand. In the demand side, we were increasing the demand, increasing the education, public awareness concerning water safety. We did all our best to improve the efficiency. Until now, we were successful. For example, we were trying to work with the irrigation improvement project for reduced seepage. We were working to improve irrigation, of course, reduce seepage by lining canals. Rehabilitation of the old canals, we do canal lining. In order to reduce the seepage, we had to work improving irrigation efficiency, applying better irrigation system efficiency. We increased the education and raising capacity, and of course, we were taking care of women and minors. We were working. This I would like to say, 20 years ago, when I was a young engineer, it was almost out of our mind that we would go to treat drainage water. The only possible option that we had, when the water quality of the drains are in appropriate conditions that comply with the standards, then we can mix with fresh water. But all these options are finished. We used all the possible options. In this case, we started now to think about treating water. It was almost a dream that we think that to treat 6 or 7.5 million cubic meter a day in the new Delta project, or 5.6 million cubic meter in Bahr el-Bar. 1 million, what DRI and NWRC were doing during the last maybe 50 years now. We started, or we implemented a national water quantity and quality monitoring program. We were participating in setting the national water quality standards, effectively hand by hand with the people from different organizations, from different ministries. We were conducting intensive water quality assessment studies along all the Nile Delta and also in the Upper Egypt to define exactly what are the appropriate practice and management approaches. We were working to define where and when to use. We were disseminating information concerning water quality. Of course, this is not only Drainage Research Institute. This task is done by 3 institutes. Drainage Research Institute is responsible for the irrigation and drainage canals. Nile Research Institute is responsible for the Nile water, and Groundwater Research Institute is responsible for groundwater. All this, we did development of tailor-made protocol to assess water quality data, to assess the quality and quantity trends in terms of spatial and temporal. We developed Egyptian Water Quality Index for drainage water use. This was tailor-made for the Egyptian water conditions. Conducting feasibility and EIA studies for the project. Conducting regular assessment. And these are some of the data as I can present here. You can, using this map, you can go for any point in the system and you can define water quality for most important water quality parameters in the system. This is the practice. If the quality of the water in the drainage system is good enough, then we can mix. Good enough means that it complies with the water quality standards. If not, then we can use either natural-based solution for constructing wetlands to improve the quality, to treat the water before reusing, or a very good example, Bahr al-Bar treatment plant is tertiary treatment system to use this water for to mix with the water coming from the Salam Canal to be used in the Sheikh Gabon project. Success story is now we are able to reuse 21 billion cubic meter to fill the gap between the 80 and the 59. The question is, what will be in the future? We have four mega projects. The Salam Canal project, this is an old one, but now after the adding 5.6 million cubic meter per day is coming from the new Bahr al-Bar treatment. We have also the new Delta barrage and the Mahsaba. In total, 5.6 is coming, 1 and 7.5. So this will bring something like 4.2 or 4.3 billion cubic meter to be treated and added to the budget I was presenting before. Yes, 4.8. So the non-traditional water resources, instead of 20, we are planning to reach 25.8. The question is, what are still needed? We need more water. Population is increasing, water is limited, and we are recycling with all the challenges related to the recycling. We need, at the end, we need more water. Not only more water, good drainage water quality. We need water quality that is appropriate either for using directly or for reusing. The most important point with all this excessive reuse of drainage water, whatever the quality is salinity, because all these treatment projects do not deal with the problem of high salinity. More reuse means more elevated levels of salinity in the soil and in the water. As I give an example, we are adding only from the irrigation and drainage water, we are adding about, it is a rough estimate, about 30 million tons of salts on the Nile Delta every year. So we need very carefully to think how, if we improve the irrigation efficiency, improving irrigation efficiency means less water, less drainage water. If we have less drainage water, means we have less salt that comes out of the system. This means there will be accumulation of salt in the soil. So what we gain from the water side, we may, I hope not, we may lose in terms of soil salinity problems. We do, or are we able to think about drainage water desalination for agriculture? What type of business model that can be feasible? And what are the long-term impact? We have to think, like 20 or 30 years ago, we were never thinking for treating drainage water. If anyone opened this subject 20 years ago, we would say that he's totally crazy. Now we were forced to do this. Maybe it is the time to come to think, are we able or we need to think for desalination or not? Of course, most important is how to find a business model. Technically it is possible, but economically, is it possible or not? I set some research needs. I will read it very fast, only for Dr. Hussein. Developing master plan for enhancing agricultural drainage water reuse. We need to analyze financial and socio-economic and environmental impacts. Continuously reusing. What will be the impact of this? Conducting baseline studies for soil salinity levels, because sometimes, I know that theory has a good effort on this, also in NWRC, but we need to have a unified work, collaborative work, to have a baseline saline map for all the Nile Delta of Egypt, or maybe all for all Egypt, investigating the salt accumulation rates in irrigated land, and what will be the impacts of such accumulation. Conducting precise water and salt balance studies to identify salt load that have to be removed from the Nile Delta. We have to work very hard to maintain the level of salinity. We need also to develop and sustain the monitoring programs for both water and soil systems to assess the long-term impacts of the drainage water use. Thank you, and I'm sorry for talking too much.
Thank you, Dr. Shaban, for your impressive presentation. And now we will move to the next presentation. Of course, all of us know that rainwater harvesting is a very important issue to Egypt now. It's in very brief a process of collecting and storing rainfall water rather than allowing it to run off, making many risks such as flash floods. Also, we may know that many communities are depending mainly on rainwater harvesting in order to provide their communities with water, or drinking water, for example. And as far as I know, that Mexico City, for example, 32% from its population is depending on rainwater harvesting in drinking, in the process of drinking water. Also, we have many countries in the Arab region are mainly depending on the rainwater harvesting, such as Saudi Arabia, United Arab Emirates, and Yemen, especially after the events which occurred in the last years. Based on that, I invite Engineer Mustafa Shalan to give his presentation to us about the rainwater harvesting as a main strategy for sustainable water use. And he will give us an idea about our experience in the rainwater harvesting, especially in Sinai region. Engineer Mustafa is a research assistant and hydrology expert in Water Resource Research Institute. He already has his master degree from Ain Shams University, and currently he is a PhD student with the same university. Finally, his main research areas are in surface hydrology, flood risk assessment, and machine learning for flood risk analysis. Engineer Mustafa, the floor is yours now. Go on.
Okay, thank you. I'm Engineer Mustafa Shal in Water Research Institute. I am an hydrology engineer, and today I will explain to you a real success story in South Sinai, especially in St. Catherine City. And this is my presentation outline. And I will start with water resource challenges in Egypt. And after that, I will talk about the rainwater harvesting success story. And the next slides, I northern coast. And as you see in this graph, there is an decrease in rainfall trend over Egypt as we analyzed the three different rainfall stations, especially in Red Sea, also in Sinai, and also in the northern coast. Since 2010, we noticed that there is the frequency of flash flood and sudden storm have been increased, and the number of affected cities in Egypt are increased also. So, in order to collect this water, in order to use this water for small communities, especially in arid and semi-arid regions, so the rainwater harvesting is the best solution. Rainwater harvesting is essential tool for development non-conventional water resources. Also, water harvesting provides a source of non-conventional water, and it is a kind of climate change adaptation. This is my case study in South Sinai Governorate, especially in St. Catherine City. As you see in this photo, St. Catherine City have characteristic of mountainous area, also with small depressions. It's characterized by many tourist attractions, especially in religious tourism. The communities are Bedouin peoples, and depending on hardening, there is no natural surface water in the city, and the rainfall distribution over the city is non-uniform. And we notice that there is a deterioration of groundwater aquifer in some regions, and also the city has suffered from flash flood hazard. The objective of my work is to try to develop unconventional water resources like rainwater harvesting, also to try to recharge groundwater aquifer, and for cultivating medicine, herbs, and vegetables. Also, the last objective is trying to mitigate flash flood hazard in the city. The first stage in my work, we had several meetings with Bedouin people and stakeholders, and they recommended to us 240 locations. Also, we make an intellectual interview in order to know the lifestyle of these people. As you see in this graph, this is the watershed area of Wadi Quran. The blue lines represent the stream lines, and the green point represents the recommended potential site from Bedouin people and stakeholders. We firstly collecting different rainfall data from different nearby rainfall stations, and after that we define all the affected wells inside our area. After that we make different technical studies like meteorological, geological, topographic, and hydrological studies. And our team make a field survey in the site in order to survey all these locations in order to calculate the storage capacity of these lakes. Also, we make some laboratory tests for soil and rocks and stones in order to choose the best material. After that, we make a tender document and develop quantities for all the project.
5 minutes.
Okay. As we see, these are the outcome of our project. 240 lake, each storage capacity about 500,000 cubic meter per one event. Bedouin people are using this water for drinking and for cultivation. Also, the implementation phase, in order to guarantee the sustainability of the project, we try to recharge the aquifer by digging new wells and fixing all the existing wells. Also, we stabilize some solar panels in the wells. And this, after that, we implement some greenhouses in different locations, and the Bedouin people began to plant different vegetables and different medicine herbs. And different vegetables from the project. The output of my project is related to Nexus perspective, food, water, energy. We succeed in collecting different rainwater, and also we succeed in making new recharge for the groundwater aquifer, and we succeed in stabilizing the different solar cells, and also we succeed in planting different vegetables. It can be included that rainwater harvesting using low-cost technique like mountain lakes can enhance the efficient use of water in arid and semi-arid regions like South Sudan. The storage capacity of each lake about 2,000 cubic meters. This amount is very sufficient for several families in these regions because the rainwater is seasonal in these regions, so the water should be integrated with groundwater in order to guarantee the sustainability of the project. Also, the income from the cultivating different crop in greenhouses using rainfall harvesting affect positively and economic and environmental situation in the study area. The total income of the greenhouses covered its cost and was more profitable. It can be recommended to apply the same scenario or the same project in different regions with the similar natural conditions.
Thank you, Engineer Mustafa, for being restricted with time. Now I'm inviting Dr. Ines Abu Talib to present a case study about urban water recycling systems. Dr. Ines is a professor of wastewater treatment technology and environmental studies National Research Center. She was a former chief executive officer of Egyptian Environmental Affairs Agency, WEAA. It's a well-known organization. She has over 30 years of national and international experience in the field of wastewater treatment and control for municipal and industrial wastewater. Dr. Abu Talib was also the principal investigator for more than 35 national environmental projects and cooperates in 80 national projects, many of which resulted in full-scale treatment plan implementations in Egypt here. Finally, she has 2 accepted patents. The first one is method for the preparation of membrane to remove ion of elements. The second one is innovative model for the application of electrochemical oxidation of high organic load wastewater. The floor is you, Dr. Ines, and go ahead.
بسم الله الرحمن الرحيم. أولا شكرا على الدعوة الكريمة وأنا سعيدة بوجودي مع حضراتكم النهارده. وإن شاء الله يبقى الكلمة بتاعتي صغيرة سريعة إن شاء الله مفيدة. Water in Egypt has facing some problem and limited, as our colleagues illustrate in previous lecture. We try to find another source of water as non-conventional and non-traditional source of water, as we use wastewater treated as new source in water. The more the largest uses after agriculture is industrial use, more than 6.7% of water consumption. So we need to try to find a solution to use smart way to management the water and apply the more efficient treatment technologies for reused water. Water management, we will deal in this presentation as how to recycle and reuse the wastewater produced from industry by using innovative technologies. First of all, we in industry we use water we use in the processes of production the products, and uses also in utilities such as chiller or boiler. First of all, we utilize the water by closed circuit, apply the closed circuit technique to reduce water consumption and reduce water and reduce the water uses. In utilities, we use a chiller or softener and boiler. We also recycle these utilities. In processed water, we suggest that the most effective technologies to use less than water in cleaning and segregate the hot spot of pollution and treat it. Our lecture here to focus on the most advanced treatment technologies used in wastewater produced from industry. First, biological treatment with membrane filtration to produce high quality reusable water, membrane bioreactor, and we use reverse osmosis for eliminate the salinity produced from many process in factories, and electrochemical treatment as a technique. My preferred technique to use electrochemical treatment. I will focus on it in this presentation. And advanced oxidation process. When we select the most suitable technique for treatment the waste, we use this after segregate the waste and select the most suitable way to produce high efficient water we can use again. First, membrane bioreactor. Membrane bioreactor is widely used in industry, and this use minimum space or footprint efficient, and give more efficient water produced can be used after disinfection in the processes again, but we select this according to the type of industry. Advanced oxidation processes, this is use mainly chemicals and some additives to make vigorous condition to oxidate every contaminant used exists in water to reach the governmental legislation. Advanced oxidation may be used photochemical or chemical. Photochemical, we use ultraviolet or hydrogen peroxide with ultraviolet with some oxidant material. And using chemical only, we can use anodic oxidation or adding some electro-phaeton reaction by using electro and hydrogen peroxide to cut all the and degrade all the contaminant and pollutant. The most effective and green technology can use in removal and treatment wastewater, we can use electrochemistry. Electrochemistry can use electro-oxidation by can divide it into coagulation and electrophosphoration, electro-disinfection. We can use electro as a part to can make treatment technology and concentration of all contaminant will be reduced, and also can reduce the TDS, salinity, and take minimum time without and have good footprint also. Case studies we apply electrochemistry. We can take the challenges of the availability space. We can use it to make wastewater treatment plant, and we have in this in beverages case study in Bursaid, Pepsi Cola have only space 240 متر مكعب per day يعني sheet discharge 240 متر مكعب per day. We have only 8 cubic meter, 8 square meter available area to make a wastewater treatment plant. This is can be a challenge, but we apply this wastewater treatment plant, and the waste reduce the COD will take place by 95%, and we meet our regulatory of Pepsi. Also, we use electrochemistry, electro-oxidation, by using electro-oxidation in petrochemical petroleum companies in Mostorot, and remove all phenols from the drainage, avoiding discharge in Ismailia Canal, and make removal 100% of H2S and phenol. Finally, we recommend electrochemical technology as electrochemical oxidation, electrochemical coagulation, because it gives us good footprint and good time for removing the waste of the pollutant. I just illustrate something here. In electrocoagulation, we doesn't need to add any chemical, just we add the electrodes, and we use EC current, which DC current, which make more efficient energy consumption to give more efficient water complying with the municipality. كتير. In electro-oxidation, we just use electrodes without any additives, and also minimum time used in case of oil and gas. We use 10 minutes only to remove all phenolic compound and concentrate accepted with regulatory standard. Thank you.
Thank you, Dr. Ines. Now we have panel discussion. I think we need to invite the three presenters here to be on the podium here in the chair, and if anyone need to ask them about their presentation, we go ahead. Shaban, please. Between Mustafa. Any question? One. Okay.
السلام عليكم. الدكتور عبد الله من معهد الميكانيكا والكهرباء. بس سؤالي للدكتور ايناس بالنسبه للالكترون اناليسيس في الووتر تريتمنت حضرتك ما اتكلمتيش على الانرجي كونسامشن. واللي اعرفه ان الالكترون اناليسيس يعني الانرجي كونسامشن بتاعته عاليه شويه عن بقيه الطرق اللي احنا عارفينها في الووتر تريتمنت. كلمينا شويه عن موضوع الانرجي كونسامشن. المفروض التشالنج بتاعنا هو الانرجي كونسامشن في الووتر تريتمنت.
الكترو بيستخدم دي سي فولت. دي سي فولت يعني بيحتاج بس محول يحول الكهرباء الاي سي لدي سي فولت. الالكترو داياليسيس او الالكترو اوكسيديشن او الالكترو كواجوليشن الكباستي بيلدينج في الاول هي بس الكابيتال كوست اللي احنا بندفعها في الاول عشان نعمل المحطه، هو ده التكاليف الاساسيه بتاعتها.
هو انا بتكلم هو كام كيلو للمتر مكعب؟
لكن
يعني كام كيلو باور، كيلو وات باور للمتر مكعب، هو ده الانرجي كونسامشن بتاعنا للووتر.
هو الانرجي كونسامشن انا مش حاسباها في الوقت الحالي، لكن الانرجي كونسامشن ريزونبل ذان اني تكنولوجي. حضرتك دايما بنقول ان الالكترو هو بيستهلك كهرباء كتير، بيستهلك طاقه كتير، لكن هو فعليا احنا لما جربناه واشتغلناه كمحطه تجريبيه في مصنع في منطقه مستورد اللي هي فيها المنطقه البتروليه، كانت efficient زي البيولوجيكال. حضرتك البيولوجيكال بنستخدم ريشن وبنستخدم بلورز كتيره، وبيحصل فاولنج ساعات للممبرين لو بنستخدمه ونرجع نعمل باكوش. فهي الفكره ان احنا في الالكترو، لا الكترو داياليسيس او الكترو كواجوليشن او الكترو اوكسيديشن بيبقى مور افيشنت لما يكون عندي حاجتين مهمين، لما يكون ما عنديش مساحه كبيره، لما يكون عندي تايم ليميتد للمعالجه، يعني كميات كبيره. انا بعالج كميه كبيره جدا في وقت قليل. يعني انا كنت بعالج 2000 متر مكعب في ثلث ساعه. انا كان نفسي يبقى معايا مثلا، الحقيقه ما كنتش محضره المحاضره، بس انا عملت المعالجه للمجازر. حضرتك عارف ان معالجه المجازر تكاليفها كبيره واستخدام مالتي ستيج عشان تشيل البلاد وتشيل كل الاورجانيك كومبوننت. اتعملت كلها الميه داخله خارجه في ثلث ساعه يتكسر فيها كل الكومبوننت. بالتكاليف بتاعتها لما اتعملت لها دراسه جدوى كانت مور افيشنت عن المعالجه البيولوجيكال اللي هي انيروبيك.
شكرا كمان.
شكرا دكتور حسين. دكتور محمد شعبان، السؤال لحضرتك. معلش بقى حسين قطع كذا مره. حضرتك قلت رقم حكايه كميه الاملاح اللي بتضاف طبقا لكميه الميه اللي بتضاف للارض مع التركيز بتاع كل متر، كل لتر او كل متر مكعب، كميه كبيره جدا جدا. هل ده ناتج عن طريق عمل سولت بالانس، يعني الكميه اللي داخل واللي خارج من المصارف، خاصه ان المعهد الحمد لله سمع المصارف بتخرج قد ايه؟ هل ده الناتج النت بتاع اضافه الارض ولا ده استيميشن بس اللي هيدخل بدون ما عملنا نعمل بالانس للموضوع؟
شكرا يا دكتور جمال. يعني انا قلت احنا حسبنا او انا حسبت الكميه دي على اساس انا عندي 40 مليار متر مكعب بيخش كده، وافترضت انه الملوحه بتاعتهم تتراوح من 350 ل 400. فبنتكلم الكلام ده بيديني رقم ما بين 14 ل 16 مليون طن ملح. ده كميه الميه بتاعت الري بس. لو افترضنا انه كميه ميه الصرف اللي انا بعيد استخدامها في الدلتا تتراوح من رقم بين 5.5 ل 7، فبنتكلم في تاني 6 مليون طن ملح. لو انا قعدت استخدام، انا هفترض بس ان انا قعدت استخدام ده مرتين بس، فبنتكلم لما نضرب 6 في 2 في 12 ونجمع عليهم ال 18 التانيين ولا 16 التانيين، فرقم بيقرب من 30 مليون طن. وانا ما عملتش حاجه، ده انا بستخدم ميه، يعني انا افترضت ان ميه الصرف ملوحتها 800 وميه النيل ملوحتها تتراوح من 350 ل 400. فانا ولا دخلت معايا انبوت جاي من السولت ووتر انتروجن ولا من الاجريكلتشر براكتس ولا اي حاجه. انا بس بقول ان انا عندي رقم ضخم من الاملاح انا ضفته للدلتا، محتاجين نفكر بقى هنتعامل معاه ازاي. انا بقول كده ليه؟ لانه بتقابلنا دلوقتي او هتقابلنا بعد شويه مشكله التخلص من مياه الصرف الزراعي. هتوديها فين؟ نيجي نوديها في الحته اكس، يقول لا ده في استثمارات كبيره ومحتاجين نحافظ عليها وما ينفعش تودي هنا. طب نيجي نرميها هنا، لا اصل احنا عندنا اتفاقات دوليه مع اماكن اخرى وبالتالي ما نقدرش نصرف هنا. السؤال اللي هيبتدي يعني، او انا متوقع انه يطرح بعد شويه، طب واحنا هنودي الميه دي فين؟ وانا بالنسبه لي مش مهم الميه، انا مش عاوز افقد ميه. انا عاوز اتخلص من الملح. والطريقه الوحيده اللي احنا فيها لغايه دلوقتي اذا استبعدنا حاله الديسالينيشن ان انا اتخلص من الميه من الملح في صوره دائمه في المياه. فبالتالي انا صحيح بفقد ميه، لكن هذه المياه انا مضطر والا هفقد الدلتا كلها. يعني هي مجرد فيري راف استيميت لكميه الاملاح اللي داخله بدون تفاصيل. دي مجرد بس شويه ارقام بالكميه والنوعيه. شكرا.
دكتور محسن. طبعا بس يعني طبعا الموضوع ده محتاج ان هو مزيد من الدراسه ومزيد من الابحاث عشان والكوبريشن كمان ما بين اكتر من انتيتي في الدوله هنا عشان نقدر زي ما الدكتور شعبان طرح الميه اللي هنوديها فين. ده نقطه مهمه جدا لازم نبقى عارفين نجاوبها في المستقبل. دكتور محسن اتفضل.
عاوز بس يا دكتور، على فكره انا كتبت كده في ريسيرش نيد. احنا محتاجين ما نعملش بقى رف استيميت، محتاجين بريسايز اكيوريت استيميشن فور ذا سولت ووتر بالانس ان ذا نايل. يعني دي من الحاجات اللي احنا محتاجين نشتغل عليها كويس في الفتره اللي جايه. انا اسف يا دكتور محسن.
سؤالي بس يا دكتور، احنا بعد اذن حضرتك سواء بنعمل الكترو اناليسيس او الكترو اوبسرفيشن او كو اجريشن او ايفر، الحاجه الوعيده فيها اللي بتشيل الاملاح، تمام؟ وحضرتك قلت بتعملي 2000 متر مكعب في ثلث ساعه. طب احنا عندنا مشكله دلوقتي بنتكلم على محطه بحر البقر، لو طلعت ملوحه 2000 فاحنا عايزين بعد ما تطلع الميه، طبعا المعالجات تمت زي الفل، الوتر بقى جاهز انه يستخدم في الري، بس طبعا الراجل الكتير هيعمل اكيوميليشن في املاح. هو في سؤال، هل لو احنا قدرنا الميه اللي طالعه نطبق عليها فكره الالكتروداس، انا بتكلم على الحاله الاقتصاديه، حاجه اقتصاديا هتبقى موفره ولا لا؟ وبعدين بعد كده الحاجه الثانيه المهمه، الميه اللي طالعه من الالكتروداس او الالكترو اوكسيديشن او الفيفر، الوتر كواليتي نوعيتها ايه؟ هل تصلح للزراعه؟ هل فيها عناصر ما زالت؟ احنا محتاجين نيوترانس، محتاجين مغذيات كبرى ومغذيات صغرى والكلام ده كله موجود. هل الكلام ده مشان ولا لا؟ يعني هل بتطلع قريبه من ديستل الوتر اللي مالهاش اي قيمه ولا بيبقى فيها بعض الاملاح؟ شكرا.
الميزه في الالكترو ان هو بيبقى سبيشاليزد عند بوتنشال معين، ده عند تايم معين بيشيل كومبوننت محدده. ففي الالكترو ديسالينيشن، الالكترو داياليسيس هيشيل الملح، هيكسر الملح، يعمل تكسير للملح عند بوتنشال محدد، وما بيجيش ناحيه بقيه البارامتر، يعني ما بيكسرش الفوسفات ولا بيكسر النيوترينت، بيفضل زي ما هو. احنا خدنا عينات فعليه من ميه بحر البقر وعملنا تجارب عليها في المعمل، وخدنا عينات من محطات اللي موجوده في دمياط ومدينه الحمام علشان عندهم مشاكل في بعد المعالجه السالينيتي بتاعت الميه اعلى من الميه اللي ممكن يستخدموها. فكان انها تستخدم هي دلوقتي انا بعمل في مرحله الاوبتمايزيشن، يعني كميه الكهرباء اللي هتستخدمها، الالكترودات دي هتتغير بعد قد ايه، حجم الالكترود وحجم المحطه بتاخد وقت قد ايه. برضو ده في المرحله اللي احنا بنعملها دلوقتي، وده بيننا وبين هيئه المجتمعات في تعاقد بين المركز القومي للبحوث وهيئه المجتمعات. ان شاء الله اول ما تطلع النتائج اعرفها على حضرتك.
في اي اسئله ثانيه؟ اتفضل.
مساء الخير، عندي سؤال لباشمهندس مصطفى. دلوقتي حضرتك قلت ان الميه اللي بيتم تخزينها، مياه المطر اللي بيتم تخزينها بتستخدم للشرب والزراعه. فهي طبعا دي ميه المطر صحيح بتبقى ميه نظيفه، ولكن لما بتتخزن شهر او 2 أو 3 ممكن الكواليتي بتاعتها تتاثر. فهل في اي بارامترز بتقاس انها تشوف الميه دي صالحه للشرب ولا لا، وحتى لو في تربيه اغنام عليها كده انها ما يبقاش فيه تاثير سلبي على الصحه بتاعت السكان او الاغنام؟
تمام، شكرا جدا. بالنسبه لوقت الشرب دايما بيبقى لهم طريقه دايما في الفلتريشن بتاع الميه، ودايما بيستخدموها في الفترات اللي قريبه من فتره الايفنت، انما بعد كده بيستخدموها في الرعي بالنسبه للاغنام وكده. بعد كده لو الميه دي فضلت موجوده مثلا فتره شهر او شهر ونص، دايما بيلجأوا ان هم يستخدموها في الرعي بس. و ليهم كرايتيريا او طريقه ان هم اوريدي بيستخدموا الميه دي باي جرافيتي، ان هم يوصلوها لاقرب مكان وبيستخدموها في الزراعه. يعني برضه حتى نقل الميه من الاب ستريم ووتر شيدز بتنقل عن طريق بعض التكنيكس يعتبر باي جرافيتي، وبيستخدموها وبيدخلوها داخل الصوب الزراعيه. حتى برضه استخدام الميه ما بيستخدمش اي مثلا وقود او اي حاجه، يعتبر كل المشروع قايم على فكره ان هو دايما اقل تكاليف.
سؤال للباشمهندس مصطفى، النموذج اللي انت طورته هل هو ليه محددات رئيسيه ولا يمكن اللي هو نطلق عليه ان هو ديمو موديل، بمعنى اخر اللي احنا ممكن نطبقه في مناطق ثانيه غير منطقه الدراسه؟ وبرضه النقطه الثانيه حضرتك قلت ان هو منخفض التكلفه، هل ده بناء على دراسه اقتصاديه ولا حضرتك بنيت المسمى ده على الظروف اللي انت بنيت فيها النموذج؟
بالنسبه لفكره اللو كوست ده، هو يعتبر بالنسبه لكل الكونستراكشن ماتيريال اوريدي يعتبر موجوده في الفيلد، زي الروك والستونز كلها موجوده في الفيلد. الحاجه الوحيده اللي كانت بتتورد بس من بره هي الاسمنت اللي بتستخدم في الانشاء. ولو احنا عاوزين نطبق المشروع ده في اكثر منطقه، لازم نشوف نفس الظروف المناخيه اللي دايما بتتكرر في اكثر منطقه بنفس الظروف، وفي نفس الوقت لازم يكون في اند يوزر يقدر يستفيد من المشروع، مش مجرد ان انا بعمله في اماكن ومفيش اند يوزر هيستفيد منه، بحيث ان هو يضمن بعد كده ان يبقى في استدامه للمشروع، وفي نفس الوقت يقدر يعمل عمليات الصيانه لكل الاعمال اللي احنا بننفذها. شكرا.
معلش تعليق على الكلام بتاع المهندس مصطفى. هي البحيرات الجبليه دي اوريدي المكان اللي موجود فيه هي اوريدي عامله فجوات، يعني هي اوريدي معموله زي بونز كده، فانا بهذب البونز دي بستراكشر بسيط جدا، كل الماتيريال بتاعته جايه من الارض. فده السبب ان هي لو كوست، عكس تكلفه اي سدود بتتعمل او اي ارتفيشال ليكس بتتعمل للحصاد، بتبقى معموله مثلا خرسانه والحاجات دي، اوريدي بتبقى تكلفتها غاليه.
دي بتبقى ناتشرال بونز كده.
بالظبط، ناتشرال بونز طبيعيه انا بهذبها عشان تقدر انها تستوعب ويبقى ليها سعه تستوعب كميات الميه. طبعا ده مش معناه ان انا ما بدرسش، لا انا بدرس هيدرولوجي، بدرس استراكشر للمنشأ الصغير ده، وبقدر اقيم السعه التخزينيه اللي موجوده في البحيرات.
في اي اسئله ثانيه؟ اتفضل.
دكتور محمد ماهر، استاذ هندسه الزراعه واستاذ كليه الزراعه جامعه المنصوره. سؤال الدكتور محمد بس استفسار بس، هو حضرتك عملت دراسه على المصارف؟
انا ما عملتش دراسه
او في حاجه بس انا عاوز اوصل لها، ان في عاده استخدام ميه بتنزل في الترعه.
تمام.
مش ما بتروحش المصارف خالص، نتيجه ان مزارعين كتير بينزل الميه بدل ما ينزلها على المصرف او القناه الصغيره وبعد ما يوديها على المصرف، لا ده هو بينزلها مباشر على الترعه. رابع مره او خامس مره استخدم ميه صرف.
انا ما قلتش كده.
لا بقول بس انا عارف انت تاثيراتك بس.
لا طبعا ما عشان كده بقول الموضوع محتاج شغل كبير. انا يعني من ضمن التحديات اللي انا عرفتها في الورقه بتاعه يعني الكومبلكسيتي بتاعت السيستم سواء كان ري او صرف، انت بتتكلم في مساحات واطوال كبيره جدا، فانك انت تكنترول يعني ان انا اعمل ووتر بالانس دقيق، ده موضوع مش سهل بالنسبه للمنظومه.
هي عرضت على منطقه صغيره
او احنا مش عايزين نعملها على منطقه
معينه.
هي هتعملها على منطقه، هيحصل ايه؟ انك هتيجي تعمل بعد كده اب سكيلينج وتعمل شويه اسامبشنز مش هيبقى بريسايز. ازاي بقى نعملها بحيث انها تديني اكبر قدر ممكن من الدقه؟ هو ده اللي احنا محتاجين نشتغل عليه. لكن اللي انا قلته ده فيري راف اسمي طبعا المعهد والمركز ومعاهد الثلاثه شغالين على الموضوع ده من سنوات، وفي بابليكيشنز كتير اساتذتنا اشتغلوا فيها وطلعوها، وفي جهد كبير اتعمل. انا بس بحاول ان الراجل زميلي ده اللي عمال يطلع لي الورقه كل شويه فما كنتش عارف اعرف كويس، انما بصفه عامه لا ان شاء الله لو حضرتك حابب
بس هي موجوده.
لا موجوده في الموضوع.
شكلك مش عايز تفتح عايز شكرا. هو انا بس ليا سؤال لحضرتك يا دكتور محمد، بس احنا بنتكلم في البوتنشاليتي بتاعه الديسالينيشن واستخدامها للديسالينيشن درينج ووتر واستخدامه في الاريجيشن، هل في بوتنشال عالي للامور اللي زي دي في الدوله دلوقتي؟
هو خليني اقول تاني، انا مش عاوز ابقى، لان انا عارف احنا لو فتحنا الباب بالسؤال ده في تقريبا 50% من الناس هيرفض و50% من الناس هتوافق. خلينا نكون احنا المفروض بنفكر بشكل علمي، المفروض كل الاختيارات مفتوحه وبندرسها كلها. المعيار النهائي في الاخر العائد المادي اللي هيجي لي من هذا الموضوع. لو انا في الاخر عملت مشروع وكلفته 100 جنيه وهو في الاخر جاب لي 50، انا خسران. حتى لو التكنولوجيا ناجحه وجابت لي كميه ميه مظبوطه واشتغلت بيها كويس. الموضوع محتاج ان احنا نبحث مش على التكنولوجي موجوده والنو هاو موجوده وبنعملها. وفي تجارب زي اسبانيا واعتقد في دول عربيه زي المغرب واشتغلوا في الموضوع ده. السؤال هل احنا قادرين على ان احنا نطبق؟ وانا رايي الشخصي وارجو ان لا يحذف من المطبقه انه الوضع التطبيقات العلميه التي تنجح او تفشل في اماكن اخرى من وارد جدا انها تيجي هنا تتقلب. يعني ما ينجح في دوله قد لا ينجح عندنا، وما يفشل هناك قد لا يفشل عندنا. احنا محتاجين نجرب ونشوف وندرس very honestly المكاسب والتكاليف ونقرر بعدها ان احنا كنا محتاجين نمشي في السكه دي ولا لا. بس هو السؤال اللي بيجبرني على هذا التمرين انه الاملاح عمليه اعاده الاستخدام ليست اوبن اند. يعني الكلام اللي بيتقال زيرو ليكويد ديسشارج سليم، بس انا لازم اتخلص من الملح. هتخلص من الملح يا اما زائد في الميه عن طريق الليتشنج ريكوايرمنت، يا اما المشروع بتاع اميسال، شركه اميسال اللي موجوده في الفيوم هو مش بيتخلص من الميه، بيطلع الملح من الملح. فاحنا محتاجين نفكر في التكنولوجي المناسبه اللي تجيب لي عائد اقتصادي جيد في هذا الوقت. شكرا.
دلوقتي لو حلينا مشكله الميه، الملح هيختلف من الميه، حلينا مشكله التربه اللي اتملحت؟
لا. هو ما احنا محتاجين نرجع تاني للصوت بالانس. انا لسه كنت بتناقش مع زمايلنا في المعهد من حاجه احنا لاحظناها. يعني انا بشتغل في معهد الصرف من 93 وبنجمع بيانات عن نوعيه المياه. اساتذتنا اللي قبلينا عملوا شبكه مراقبه جيده وناجحه وشغاله. فانا لاحظت انه مصارف زي مصارف سينا فارما وبلوزه كانت ملوحتها 15,000 جزء في المليون و17,000 جزء في المليون من حوالي 15-20 سنه. دلوقتي الرقم بقى 5,000 و7,000. ده معناه انه في غسيل، حصل غسيل للتربه والملوحه بتقل. طب ما هو نفس الحكايه دي لم تحدث في غرب الدلتا. غرب الدلتا بقى لنا سنين طويله والملوحه فيها مستوى ما بتنزلش. فهنا لازم نبحث عن مصدر الملح. هل هو الملح هو قطاع الملح في قطاع التربه؟ في الحاله دي يبقى العلاج بسيط معروف، الصرف والتخلص من هذه الاملاح عن اضافه الاحتياجات الغذائيه والتخلص منها. لكن ربما تكون في مصادر اخرى مثلا انه يبقى في ابليفت من الاملاح من المياه الجوفيه، ممكن يكون في ملح جاي من السولت ووتر انتروجن. يعني القصه انا يعني مش بصعب الحكايه، لكن محتاجه انها دراسه قويه اعرف بالظبط مصدر الملح. دوري انا في الجزء الخاص بتاع الزراعه ان انا امنتين على الاقل، مش اذا ما كنتش قادر ارسم قطاع التربه او اقلل ملوحه التربه، على الاقل احافظ انه ما يحصلش ضرر، وبالتالي اقدر القطعه الارض اللي انا بزرعها تستمر في الزراعه لفتره طويله. بس شكرا.
شوف احمد، يعني انا كنت بعد الصنعه الماديه الجوفيه وكان في خبرات ويشيل معانا طبعا الاستاذ الدكتور شادي في المعهد، يعني الاستاذات اللي هي موجوده هنا في المعهد صراحه دي طبعا. كنا احنا اشتغلنا في اريات، كان الدكتور صالح مدير المعهد، اشتغلنا على بعض المناطق في شمال الدلتا. هنا في منطقه الحمول والمنصور ومنطقه كده. الاراضي دي كانت طرح بحر، فكنا بنشتغل احنا فيها بالميه المملحه، بحيث ان احنا زرعنا فيها رز ورب الملاحه. والرز على فكره من ضمن المحاصيل المقاومه يعني حساسه للملوحه، مش متحمله للملوحه، ان هي بتحتاج ميه. واخد بالك؟ فكنا بنعمل غسيل سطحي، وده دير الفلاح، كانت دي فكره الفلاح نفسه. بيروي الارض بعد الفجر ويرمي 2 سم ارتفاع. الرز احنا كنا عملنا الدراسات بتاعتنا في ايام كان الهولنديين، كنا نستني المطر كان بيقولوا 10 سم. ده كان بيعملها 2 سم. يبدا يحصل حركه البلع مع الميه ويصرف قبل المغرب، يصرف يعني بيرمي قبل الفجر ويصرف بعد المغرب، فبيبدا يتخلص من الاملاح كده بتاعته، على اساس ان هو يبدا يتخلص من الاملاح يرمي ميه ملاحه عاليه. بس ملوحتها اقل من ملوحه الارض، ملوحتها اقل من فكده بيخسر. فانا بتكلم بقى ليه حته ان انت عندك الفرمه والبلوزه ديت. احنا برضه عملنا التجربه دي، كان الدكتور برضه معانا الدكتور صفوه، برضه كان في غسيل كتير جدا جدا، يعني ده اسمه ميه بحر. بعدين بدانا نتدرج ميه ملاحه، لان الملح هناك كان في المنطقه دي كان قد ميه البحر حوالي 3 مرات، غسلنا ميه بحر. بالظبط. وتدرجنا بعد كده بالملوحه مصارف لحد ما وصلنا الميه شط تقريبا كده. فطالما الميه اللي انا بحطها اقل من ملوحه التربه فليس غسيل. انت يحصل بالانس بقى زي ما بتقول عليه كده بضرب الدلتا، يمكن الميه البلد ملوحه الميه وملوحه التربه في بالانس بينهم وبعض. ممكن يكون برضه زي ما حضرتك بتقول ان في ادوار سيلت من الميه الجوفيه بتسبب النقل. فالمبدا العادي انما طالما الميه اللي انا برميها اقل من ميه الارض فبيحصل غسيل، والعكس.
احنا مش مختلفين يا دكتور، انا بس عاوز اقول انه الملح لازم هيبقى كويشن مارك في المرحله القادمه. هنتعامل معاه ازاي؟ هو ده اللي احنا محتاجين نفكر فيه.
شكرا يا دكتور شعبان، وشكرا دكتور جمال، وشكرا لكل الزملاء اللي حاضرين على هذه المناقشه السريه. يعني احنا دلوقتي انتهينا من السيشن الثانيه. لسه على السكيدول هندي 10 دقائق 10 دقائق بريك، ونيجي نكمل ان شاء الله السيشن الثاني. شكرا جزيلا ونتمنى لكم وقت طيب.
The third session, it's the last session today. I hope that you're still awake. The session is now we are going from talking about the water scarcity and the reuse and the case studies in the field and the projects to the technologies. What's the new technologies and the topic of this session, or the title of this session, is the artificial intelligence and drones for water resources management. Today's rapidly evolving world, efficient management of water resources is vital, especially in the context of agriculture, where water is a critical factor for crop growth and food production. The integration of the artificial intelligence, which is nowadays it's in almost all the fields that we are working in, and the drones, which is currently used in different fields, has changed the way of monitoring and analyzing optimizing the water uses, particularly in the agricultural landscapes. In this session, we will explore how the artificial intelligence and the drones are transforming the management of water resources in natural systems and in agriculture, where these technologies are enabling more sustainable and efficient water use. So please join us, and we will welcome Dr. Ayman Habib. Dr. Ayman Habib is a professor of geomatics or in photogrammetry and remote sensing in civil engineering from Purdue University. He also a co-director of the Civil Engineering Center for the unmanned unmanned airborne systems. So he's mainly working for drones for several years now. He will present to us one of their projects that they did in Purdue University, where they used the drones with other features and specific sensors for the digital photogrammetry, for the digital agriculture. Dr. Ayman Habib, he is the co-director of the Civil Engineering Center of Applications of UAS for Sustainable Environment. He also associated director of Purdue University Joint Transportation Research Programs and the Institute of Digital Forestry. He received his master's degree and PhD from in photogrammetry from Ohio State University, and he working now in Purdue, and as I know, he also worked in Calgary University in Canada. So we are happy that he has time to share his experience with us. And thank you, and you can start, Dr. Ayman, if you are hearing us.
Thank you very much, Dr. Nagwa. Hopefully everyone can hear me.
Yes. Yes.
Is it possible for me to share my screen?
Yes.
Can I share my screen because I have videos that would not play?
Yes, they are working with that.
So hopefully you can see my screen.
Yes.
Yes. Thank you very much, Dr. Nagwa, for giving me the opportunity to talk to you about our work in the area of using unmanned aerial vector or drones for digital agriculture. So,
may you raise your voice, Dr. Ayman, please?
okay. So, can I go here? So, digital agriculture, we are mainly interested in increasing the productivity or the crop yield. And just as a matter of information is that by 2050 we need to double our crop yield to accommodate the increase in population. And digital agriculture tools, which are mainly dealing with management of farm inputs, including irrigation, fertilizers, herbicides, seed, and fuel, to apply the right management practices at the right place, at the right time, it's very important. And this is really the key in order to increase the crop yield. So, remote sensing on board either spaceborne, airborne, or wheel-based platforms like tractors play a key role in digital agriculture in general and what we call sometimes precision agriculture in particular. And this talk I'm mainly focusing on UEVs or unmanned aerial vehicles. And maybe I will be focusing on the use of unmanned aerial vehicles for seed breeding trials, اللي هو التهجين السلسلات. So the seed breeding trials are very important because over the last, I would say, decade or so, the majority of the increase in crop yield happened because of improving the genetic consequences or constitution of the seed. So it's not really, we don't have an increase in the crop yield because of having more land. We have more yield because of the results of seed breeding trials. So what's really important for seed breeding trials is what they call genotype-phenotype correlation. So what is genotype-phenotype correlation? So for the seed, the genotype, that's basically the genetic constitution or the makeup of the plant. The phenotype, that's basically the behavior of the plant in the field as a result of its genetic constitution. So for example, the plant height, the leaf angle, the leaf area coverage, the biomass, all these are actually phenotypic traits that are impacted by the genotype. So to do gene manipulation, gene sequencing is very affordable. We can have thousands and thousands of varieties at very little cost. However, the problem or the bottleneck is correlating the genotypic traits and the phenotypic traits. And again, we really need to do this correlation because through the phenotypic traits, we identify the genotypic constitution that will give us increased crop yield while reducing the requirements for land and water, while increasing the biomass, for example, for biofuel generation, and also for modifying the plant structure to have a smaller leaf angle, which allow us to have more density of planting in the field. Also increasing the plant resistance to droughts, pests, and also a reduction in fertilizer requirement. So the way they do phenotypic data collection is that either they do destructive sampling, so they move plants from the field and they do measurement, or they do actual measurements in greenhouses, or they do manual measurements in the field. All these methods are very actually time-consuming, very expensive. They are error-prone because usually whenever you record measurements, you have higher probability of errors, and then they are destructive. So the current trend right now is that we use a remote sensing system like UEV to collect geospatial data that allow us to generate a digital twin of the field. So now we can do the phenotypic trait derivation for all the plants within my seed breeding trial. So in order, like what this talk is really focusing on, how we can use UEVs for high throughput phenotype. And that involves these 5 aspects. And I'll talk very, very briefly about each one of those aspects. So the first one is what we call sensors and platforms. So we have a variety of sensors. We have UEVs, we have tractors, we have even robotic systems that can travel through the field, or even backpack or wearable systems. So that's the sensor and platform. In this talk, I will be mainly focusing on the UEV. The second part is basically how you make sure that the data you get from the sensors on these platforms are giving you accurate geospatial data. So that's what we call system calibration. Then the second part is or the third part is that how we can derive 3D information about the field from the geospatial data collected by these platforms, and then the data processing, which we do the data analytics, and then finally the visualization. And what's really important here is that AI plays very important role in like these 3 components, the system calibration, the georeferencing, and the data processing. And then finally, the visualization for the stakeholders, for the seed breeding scientists. So let's talk about the sensor platform and mainly focusing on the UEV system. So we have a wide variety of UEV platforms that can collect data. We have a wide variety of sensors. We have navigation sensors, we have RGB cameras, we have thermal cameras, we have LiDAR, we have hyperspectral sensors that are collecting data in the visible, near infrared, and the short-wave infrared. And the key part here is that because we are trying to understand everything about the plant in our seed breeding trial. So like nitrogen content, stress level in the plant height, and so forth. So having a variety of sensors that will allow us to derive all possible phenotype of traits that allow us to identify the best gene constitution for the seed breeding trial. So this is just an example that shows actually a UEV equipped with RGB camera, hyperspectral camera, navigation unit, and a LiDAR unit. And this is just, we are looking under the hood to see the components of the navigation unit here of the UEV. And this is another implementation or another example of the UEV. So as Dr. Nagwa mentioned, we have lots of developments in the technology. New sensors are coming every few months. We have a new platform. So again, being able to accommodate the advancements in the new sensors and technology and the platforms is very important to allow us to collect geospatial data with high fidelity. And this is an example of the products we would like to get from these sensors. So for example, from the RGB imagery, you get an orthophoto that gives you very good information about the geometry. From the hyperspectral data, you have actually spectral properties that you can use to derive lots of information about the plants like nitrogen content, stress, and so forth. And we have LiDAR that gives us information about the height. So you can see here, each one of these plots is a different plot with a different gene constitution. So what we are trying to do is just how to ensure that the data coming from all these sensors align well, because we have usually very small plots. You collect some information from the imagery, some information from the LiDAR, some information from the shortwave infrared, some information from the visible near infrared, and we would like to align the data from all these sensors for a specific plot. And it could be a 2-row plot or 4-row plot, depending on the design of the seed breeding trial. Then you have the system calibration, and for seed breeding, you really are trying to observe the progress that happens to the plant over time. So here, for example, for one particular row of the seed breeding trial, we are tracking what happened to this row from June 16 all the way to August 16. So you can, this is very important to see actually the evolution of the leaf area covers. Sometimes there are some studies that are focusing on counting the number of leaves. This is where basically AI plays an important role. Determining the time where we have actually the flowering is very important, because this flowering, when the flower or the plant starts to flower, that gives us information about the yield actually, or some idea about how to predict the yield. So it's very important to make sure that we can track each row segment over time. So that's why we call the geometric calibration or the data alignment is very important. And you can see here we can even track particular plant through this period from July 25th to August 6th. We would like to do the same thing with LiDAR. So here actually LiDAR data, this is actually LiDAR data at the beginning of the season in June 10th. That's the LiDAR data in June 17. That's the LiDAR data in August 4. And this is just, we are showing cross section. So this is at the beginning of the growing season. We only have the ground. Actually at June 17, you can see that the plants are starting to emerge. And then in August 4, we can see the individual roots. In this case, that's a male. And then also what will happen in this particular data set, we have data collected not by a drone, but an airborne system. So we have an airborne system collecting data from 12,000 feet, and that's the level of humidity. And it's very important for us to make sure that the data we collected from the early season to the late season are well aligned, because we can tell actually here the behavior of the plants in the different plants. So the geometric calibration is very important. I don't really want to get into the technical details, but in a way we are trying to understand the internal characteristics of the sensors and how they are related to each other. We develop techniques actually that says actually that you have data coming from LiDAR, from different tracks, data coming from imagery, and we do an optimization using AI tools that identify common features in this data set, and we ensure that all the data sets align well. And then if we have some control, we make sure that the data set aligns with the control. So the control might be, for example, we have a terrain model of the field that we are collecting. And then we put all this, the information of the features which we get through AI tools in an optimization engine that will ensure the alignment of multi-sensor, multi-temporal, multi-platform data. Then we do the reconstruction. So I'll just very quickly talk here about, there are tools like, for example, structure from motion that gives us point cloud data from imagery. So we have well-defined tools that basically identify common features in overlapping images and use this to give us the point cloud data. So whenever we work with urban areas, the identification of common features in overlapping images is very straightforward. So this actually graph shows two overlapping images, and these lines actually connect a point in the left image with a corresponding point in the right image. So you can see actually we have the right correspondences between features in the left image and the right image, and this is the prerequisite for the structure for motion. The agricultural fields, because basically the plants, they all look at the same, so you can see here the matching between these two images are not really correct. So you should have lines in one direction. So this is because of the nature of the plants that they look quite similar. So we developed techniques to handle this problem here, and then in this case you can see that we identify the right correspondences between features in the left and right images. And then we can do that, and then we can derive very complete orthophoto. So here we are comparing this. If you are not considering some of the geometric calibration and the georeferencing, you will have gaps in your orthophoto. And then the fourth element is the data processing. And one of the important data processing activities in seed breeding trials is identifying the individual plots as well as identifying the individual row segments within the plot. Because at the end, we really need to say this plot that has this seed with certain gene sequence, that's basically the characteristics or the traits we derive. So to make a derivation of the plot is very, very important, and the row segment. So this is actually where we develop tools that, AI tools that use the LiDAR point cloud data to automatically identify the rows and the arrays. So basically the rows, these are the individual rows where we have the plant, and the arrays, those are basically the gaps between the different row segments in different row plots. So I'm not really going to bore you with the detail, but we have automated way of identifying the arrays and the rows, and this is just an example of automatically derived rows in different times. So this is in July, August, and September. So you can see all these peaks actually corresponds to the rows in different data sets. So we use those ones to identify whether the data is properly aligned or not. Because if the data is properly aligned, in this case we have the arrays or the peaks are well aligned. And then you can see something here interesting. You can see in July data we have two peaks here that corresponds to two row segments. And you don't see the peaks anymore in the August and September. And the reason actually is that it's part of the seed breeding trial. They do this what they call destructive sampling. So they actually harvest these two rows. So that's why the rows actually are appearing in July, but they are disappeared in the August and September. So having this ability to more or less track your field throughout the growing season, that's very important. That's the same thing here where we are showing the alley, which is basically these separation between the different rows. And then once we have the rows identified, we can actually isolate the data with each row segment in the liveness, in the imagery, whether they are hyperspectral imagery or RGB based. So this is actually very powerful because for a given row segment, throughout the entire growing season, we can track what happens to this row in terms of the leaf area coverage, the plant height, the stress of the plant or nitrogen content and so forth. And then this is really, to me, the visualization step is the last and most important part. So this is just, I will let this video run. So if you do this action, you can track, or more or less for your stakeholder or for your seed breeding trial, you can visualize the data. So this is actually the seed breeding trial. We have the row segments. Each one of these red rectangles is basically the one row segment. And there we are showing what's happening over time to this particular location. So we are now in July 11th. We move to July 21st. You can see that we start flowering. And then we move now to August 8th. And you can see these two rows, we did destructive sampling. And then this actually is not maize, it's sorghum for biofuel. Sorghum actually, if you touch it will grow again. So this is after the destructive sampling. So I'll let this video run again for just a few seconds, just to show, because that's really the end tool.
2 minutes, please, Dr. Ayman. 2 minutes.
Go ahead.
2 minutes, please.
Oh yes, we are almost done. So this is the seed breeding trial. Actually here, that's basically like what we are interested in, deriving these traits and show it to the seed breeding trial. So I'll let this run just for 10 seconds and then I'll move to the last slide. So you can see here, we can easily see the flowering phase, the individual plant, and then here you can see the destructive sampling that happens to these two rows, and then you can see here in August 30th, we can have the release. So in conclusion here, I would say that UED is just a tool that you put sensors in order to gather data about your field, and then this data you'd like to take into information and knowledge. And the main message I'd like to say is that for developing these systems, whether it's UEVs or other, we have to understand what are the application needs. We do the system design, we do the development, we do the calibration, we do the acquisition, we do the modeling. AI plays a very important role in the modeling, and then we do the product. And very important part here is that basically we have to understand whether the products we are delivering are correct or not. Because if you make decisions or make action based on a wrongly derived product, that's quite easy. And then you go through this stuff, and at some time, actually, after you go through all this processing change, you find out that you have to really redesign the system or redesign the data processing. So this is, I would like to acknowledge all the funding sources we received for this research. And thank you very much for your attention. Hopefully I did not take too much over.
Thank you, Dr. Ayman, for your informative presentation. It was very useful, and it's good to see that there is many things that we can do with drones, but I believe this needs also experience and experts behind that to deal with the products of the drone. I will excuse you, Dr. Sheikh, because Dr. Ayman has a commitment in 30 minutes, so can you take questions for him if there is any questions? Do you have any questions for Dr. Ayman? Can you take if no, I have a couple of questions, please, Dr. Ayman. I would like to ask, we believe that recently we will have drones in Egypt and we can use it, but until the UAVs are widely available here. What other effective digital agriculture methods can be used? I mean, if we don't have drones, can we use other platforms or what? And also, I would like to know if what's the credibility of the results if inexperienced users cross the collected data. I mean, if we have drones and we collect data, and someone that is not experienced in working with this data use software and get the results, what's the credibility of these results? Thank you.
Thank you very much, Dr. Nagwa. Those are very important questions. So maybe I'll start with the first one. So the platforms, I understand sometimes the flying, the UAV, there are some logistics. We actually, you can use the same payload and you can have it on a backpack, and you can do that actually data collection using a backpack. You can even take the payload and put it on top of a tractor that will go into the field. And right now, actually, we are also working on robotics platforms, like small uncrewed ground vehicles that can go collect the data in between the rows. So the platform, for us, is just like a vehicle. You can collect the data from different varieties of platforms. But the question which you mentioned also about the fidelity of the data, this is very, very important, because again, and we usually say this, that I mean, it's a little bit philosophical. We say that we have a democratized way of data acquisition and processing, meaning that anyone can have their own platform, can collect data, and can derive products. But the question is that are those products are good or not? So that's why, as part of the tools we develop, first we have to make sure that they are user-friendly, so we don't need high level of expertise to operate them. The second part is that we have to have quality control mechanisms that tell us whether these results are reliable or not. So before you take the results and make decisions based on these results, we have to look into these quality control, which are automatically generated, to tell you whether these are good products or not. Thank you.
Thank you very much, Dr. Ayman, and we hope we can see you soon. And yeah, you are welcome to visit us in the National Water Research Center. Thank you.
Thank
you. Going from the drones to the artificial intelligence, and now we have one of our experts in artificial intelligence and in modeling, Dr. Ahmed Samir. Dr. Ahmed Samir has his bachelor's degree and master's degree from the Yazid University in civil engineering, and he has a PhD from Tsinghua University in China in hydraulic engineering. He is working and he's experienced, he expert in remote sensing and GIS for water resources management, and in artificial intelligence, machine learning, and remote sensing data fusion, which is very important to collect the data from different sources and work with them. Satellite images, downscaling for hydrological and land surface applications, satellite-based soil moisture estimation and land surface analysis, hydraulic and agro-hydrological modeling. Thank you, Dr. Ahmed, for accepting our invitation. And yeah, the floor is yours. Thank you.
Thank you for the kind introduction. Good evening, everyone. Today we will maybe talk about two hot subjects: artificial intelligence and remote sensing. And how to integrate between these two technologies to leveraging new sources and new outputs. So my presentation on the title of Bridging Remote Sensing and Artificial Intelligence for Advanced Water Resources Management. sensing and the Digital Earth Africa platform, machine learning model for water level prediction, and downscaling service soil moisture using machine learning, and finally conclusion and future directions. For the first part, let me talk about remote sensing and artificial intelligence. Remote sensing, the main advantage of remote sensing can provide you with a huge amount of data sets, which may expand for 10 years or more than 10 years, and can cover vast areas. So it's important to make use of this kind of data to provide useful insights and useful outputs. But remote sensing is not enough to provide a kind of services, especially in water sector. So we need a kind of algorithms and models. So we can use remote sensing for input data and use artificial intelligence or some algorithms which belongs to artificial intelligence, like machine learning, to find the relationship between different inputs coming from remote sensing to provide new services or new outputs, like evapotranspiration for soil moisture, which considered two main factors or parameters or drivers that control water consumption in agriculture field. So, making use of these advancements and sources of remote sensing like public supplies, I think all of us hear about Landsat and Sentinel, and also for commercial supplies like Maxar and Airbus. There are also a lot of maybe we can call it remote sensing based products, which may produce using remote sensing inputs, like the CLDAS products, China Land Data Simulation System, and GLDAS products like Global Land Data Simulation System. We have also Era 5 land products, which may data simulation products use inputs from remote sensing to provide the new products. One of the platforms that successfully integrating between remote sensing data and artificial intelligence is Digital Earth Africa. Digital Earth Africa is an extension of Digital Earth Australia, which maybe will be developed by Australian government, and they maybe try to expand the use of it all over the world. So they have developed the Digital Earth Africa, which covered only the African continent. You have two options. If you need to use Digital Earth Africa, you can use only the map with 30 different products provided by it. Or if you need to do more analysis, to know more about programming language like Python, you can use the Africa Sandbox. Let's talk about some products from Digital Earth Africa. The first one is water observation from space. Water observation from space used remote sensing data from 3 satellites, like Landsat from 5, 6, 7, 8, and 9, I think they include 9, to classify each pixel if it's water or not water. So it can provide, using machine learning, of course, it can provide you with classification for each pixel, if it's containing water or not containing water. So one of the uses of this product, it can provide you with the water extents for water bodies. This is for Toshka Lake 2. It can also provide you with wetlands, artificial lakes, maybe also some rivers with wide, if it's wide enough to be captured by Landsat. The main feature to maybe categorize this part as maybe a water body or something like that, it should be classified as water for about 5% of total observation since 1984 till 2023. For another product, ProPlan Extensia, they have also used machine learning algorithms, I think around the forest, to classify the land covered between cropland or not cropland. They can provide maybe, I think, the cropland extent for Africa 2019. I think it's not good for us because we have changing cropland each year. But the main lesson we can learn from this is that we can use machine learning for classification of cultivated land. This will help us to categorize or to determine how many or the area of cultivated land which is very important for us to distribute waters. Also for machine learning, it can provide us the probability of this pixel, it's cropland or not cropland. So this is also something I need to say about artificial intelligence. Artificial intelligence will not maybe replace human. It will help you to take the proper decision. So it will give you a probability for this pixel. This pixel is cropland by the percentage of 75. So you have the decision to take it as cropland or not. For the last product for the Africa, the fractional cover use a kind of classification to classify the land cover between 3 categories for green pixel, not green pixel, and clear soil. It's also helpful for environmental noting and also for assessing crop health, because it's important for us to monitor the crop health if you need to increase the productivity, also for understanding the land degradation and the recovery. So another topic related to machine learning or artificial intelligence, machine learning model for water level prediction. In Egypt, we mainly depend on water levels to distribute water. So the idea comes from that we have some points in the water streams that we don't have, or don't have maybe we don't have sufficient information about the water level at this point. So maybe we have a point upstream and a point downstream this point, but we don't know exactly what the water level is this point. So we use machine learning to connect between upstream and downstream to find or determine or estimate the water level at this point. This is maybe the methodology, but we don't have time to illustrate it. Okay, so we have 3 main models, proposed models. We already applied. They differ according to the prediction time and the accuracy. We have bigger models and nested model and performance model. Performance model gives you the high performance or lowest error because it takes into consideration the 5 days levels before the day you need to estimate. This will help you maybe to cover the trend of water change, so it gives you more accurate results. And this is the output we have after using machine learning. This is the user-friendly geographical user interface for water prediction along the Nile River from highest one dam to the Delta barrages. I think, we just engineer need to choose the date. It will show you the date you need to enter for the discharge release from Aswan High Dam, and the water level at Delta barrages as an example. You just click to calculate and you use the water level at this point. The last topic I need to talk about is the scaling soil moisture using machine learning. This study was a contribution between NWRC and the Tsinghua University during my study in Tsinghua University. In this study, we try to make use of machine learning and find the relationship between different inputs like land surface temperature, NDVI, and albedo, precipitation, and soil texture, and soil moisture, because soil moisture is very important, especially in the agriculture sector, because you need to satisfy soil moisture levels to maintain the crop productivity, or maintain the crop productivity at highest level. So, soil moisture change rapidly in time and space, in small time and space. So, in maybe few meters, you can have different soil moisture values. So, we try to use remote sensing data with the help of artificial intelligence or machine learning to provide spatially temporary continuous maps of soil moisture. Maybe this is the methodology we have applied. We maybe use data from mold-based land surface temperature, land surface temperature and positive reflectance, and using downscaling approach The term of downscaling approaches for data fusion is a term related to remote sensing. It's a kind of merging between different sources of remote sensing. If you have Landsat image, it provides fine spatial resolution at 30 meters, but every 16 days. On the other hand, you have MODS products that provide 1 kilometer spatial resolution but at daily basis. So we use this SFM algorithm, this is spatial temporal data fusion algorithm, to combine between them, and finally we succeeded to provide spatial temporal continuous NDVI 30 meter and albedo at 30 meter and that system region at 30 meter at daily basis. Yeah, this is maybe describe what data fusion can do. So let me talk about landscape simulation. So this is modest landscape simulation. This is daily product at 1 kilometer spatial resolution. You can see this is 1 pixel at 1 kilometer spatial resolution. After applying the SFM algorithm, we convert this one to this one. So downscaling approach, downscaling techniques can downscale or provide more information using with the help of or combining between coarse resolution pixels and fine resolution pixels to provide this kind of borders. After applying the model, we have the outputs. This is the soil moisture data. This is the study area, 3 kilometer by 3 kilometer, represented by 100 pixel by 100 pixel from Landsat. This is the evolution or the change of soil moisture in 10 consecutive days in May 2016 for the study area. This is for different 5 scenarios because we have used different products from soil moisture products. And we can see that using this model, machine learning with remote sensing, we can provide very special detail of soil moisture across the study area. Yeah, here's some scatter plots for statistical metrics, statistical indicators for the outputs from the model. We have applied the model in one station and we try to check or validate the model over North China plan. This is 2 automatic stations and this is 5 manual stations, and we found that using these techniques help to provide I think the error of soil moisture around 3 or 4%, which comparable with other results. Finally, for conclusion and future direction, I think combining between AI and remote sensing will provide a powerful tool to make use of a huge amount of data for services like water resource management. Also, machine learning will enhance the satellite data usability. Also, platforms like Digital Earth Africa will help a lot in terms of water resource management. For future direction, I think we need to expand using AI in different branches because it's very important. And I think all over the world, we already use it. Also, we can enhance the cooperation, which we already do right now, cooperation between different research and policy makers and decision makers. Also, we need to improve the downscaling techniques, which were very important. Finally, we can leverage the use of UAV as Dr. Ayman presented the presentation, that using UAV will provide more fine resolution outputs, which will be very helpful, especially in environmental monitoring and for water resource management at the field scale. Thank you.
Thank you, Dr. Ahmed. I really appreciate that you have correct time, and we have, of course, we have a lot of questions, but we will postpone it until the end of the session. So please stay with us, and thank you again for your very informative. I don't know what I say. It's a lot of information we can get from this presentation. Thank you. And now we will go from the space to and the air to the on-farm, and we invite Professor Atif Nassar to present us for the third presentation today, which is a case study, and it's a digital tools for water productivity in Egypt. Dr. Atif Nassar holds his university degree in agriculture engineering science from Cairo University, and he has 2 master's degrees from Ain Shams and from Bari, Italy Institute. And also he has a PhD from Bari University and from Ain Shams. It's okay. Dr. Nassar is skilled in the field work, research, practical applications, drainage, smart and conventional irrigation, water management, agriculture engineering solutions, and identifying cutting-edge and granting technologies. Thank you, Dr. Atif, and please.
طبعا احنا معانا الوقت لحد الساعه 6. هم ادونا الوقت لحد الساعه 6.
الوقت مع حضرتك، بس احنا عندنا بس عايزين نعمل الاسئله وعايزين في الاخر اثناء ونرتب اليوم. غير كده بقى احنا عايزين
مع الفطار بقى، بعد الفطار بقى.
ايوه حضرتك دايما اللي بتستثني، ما بخافش الا منك. احنا هنتكلم عن مشكله دايما قايمه، هي مشكله الري. مشكله الري او الناس اللي هي بتتكلم في موديل irrigation او غيرها، احنا ما زال عندنا مشكله. المشكله بتاعتنا بتتمثل ان الناس ما زالت بتعمل ري حديث بمفهوم الري بالغرب. يعني هي الناس بتحط شبكات ري حديثه، انما بتحط كميات الميه ازيد من اللازم، فبيبقى تقريبا ما بين الري والامر اللي بالخراطيم. فاحنا فاحنا هنبتدي من الاول نقول ان هي لو الميه او الروت زون بيبقى في الطريقه دي، بتخش الميه او بتضيف كميه الميه اللي انت بتضيفها بتثبت في الريد زون عند حاجه اسمها الفيلد كاباسيتي، والباقي كله بيخرج درينج او ميه زياده. طبعا انا عندي لوسز عن طريق الافابوريشن نقدر نحسبه، وكمان في ان اديشن الميه بتاعت الري بالميه. ما بين الاثنين لو انت ما عملتش سولت بريبريشن كويس بيبقى في ميول زايده عن في التربه وتؤدي الى عمليات ران اوف. فده اول حاجه لازم نفهمها في موضوع الري، ان انا لازم اوصل التربه بتاعت الروت زون لمنطقه الفيلد كاباسيتي، وبعدين بقعد اخسر او بتستهلك الميه لحد ما ارجع اعيد تاني لملء التربه. الحاجه الثانيه لو انا ابتديت في الزراعه، انا عندي حاجات اساسيه لازم هستغلها من هنا ورايح، او لازم انا اعرفها بالسويل ريديشن اللي هي كل المعادلات الحراريه. السويل ريديشن درجات الحراره، الرطوبه، او سرعه الرياح. الحاجات دي بتتلخص في الجزء الحراري بمعادله بيلمان اللي هو بني عليها برنامج كرومر. ما زال في مصر لحد دلوقتي كل زميل اكلمه اقول له انت حسبت كميات الميه ازاي؟ يقول لي عن الكروب وقت، اقول له يبقى انت لان هو ما زال البرامج دي اللي هو اداها لنا الفاو دي امثله ازاي تحسب الحسابات، ما هياش تقدر تطبقها على مصر. عشان تطبقها على مصر لازم ترجع لمعاملات المحصول تحت الظروف المصريه، سواء كانت في كفر الشيخ مش زيها زي بني سويف، مش زيها زي اسوان. مصر متقسمه ل5 مناطق حراريه لازم نعرفها، اسوأها على الاطلاق هي اسوان.
اي فدان بيتزرع في اسوان بيقابله 3 فدان عندي في وجه بحري والمناطق والدلتا الجديده والحاجات دي. فده في اول حاجه لازم نحسبها علشان نقدر نعمل سمارت irrigation. لازم نغير مفهوم المزارع، مفهوم الزملاء كان سواء مهندسين او بعض الباحثين اللي ما زالوا بيعتقدوا ان كروب وات هو الاساس في المعاملات النباتيه او الري. احنا عندنا هنا في التربه اللي في الحاجات الحراريه لازم بنراعي برضه الصغور في النباتات والافابوترانسبيريشن بيتم ازاي، والحسابات دي بدخلها علشان ابتدي اعمل المعادلات بتاعتي. انا حبيت اديك مثال للري اللي احنا عايزينه، حاجه بسيطه خالص عشان ما نختلفش كتير. الري اللي احنا عايزينه هو الري الاولاني ده. الري الاولاني ده المربع بتاعه ده الروز زون بتاعته كل الميه فيه من الهيد للتيل بتاع الغيط، كل الميه بنفس المستوى. هتلاقي شكل الزرع من غير ما تبقى بروفيشنال في الاريجيشن سيستم ولا لا، هتلاقي شكل الزرع كله واحد، نفس الدول، نفس الكلر، نفس الحاجه. ده اللي احنا عايزينه. هتختلف شويه لو حضرتك ابتديت تلعب في عالي او واطي، او انت ابتديت تنزل كميات الميه الغير مناسبه. هتلاقي في اول الانحدارات الغير مناسبه هتلاقي عمق الميه تحت منطقه الجذور ابتدى يختلف، ابتدت في حاجات في الاوفر irrigation بيبقى فيها لوسز بطريقه كبيره. فاحنا اللي احنا عايزين نوصل له هو الصوره الاولانيه، سواء كان ري غم او كان ري بالطريق العادي او كان ري بالطريق بس محابس كهرباء بس، او كان سمارت irrigation اللي احنا بنعمله واللي بننشد ان شاء الله ان احنا نكمل التجارب عليه لحد دلوقتي. حضرتك احنا هنا عندنا 100% مثلا يونيفورميتي بقت شكل المحصول اهو، والحاجات اللي فيها نقص في الري او الحاجات الاوفر irrigation ابتدت تخرج بالزيادات. طب انا عايز اعمل مونيتورنج لهذه العمليه. عشان نعمل مونيتورنج لهذه العمليه لازم هاخد انا الحسابات بتاعتي الحراريه، هبتدي احسب معاملات التربه بتاعتي، مش هخش على الكروب وات واعمل الهيفي والكلي. ده بيدي لك مثال الراجل. لازم هتجيب التحاليل بتاعتك وحاجتك تحطها، وهبتدي اتكلم على الفترات بين الريات وكميات الري اللي انا هعملها. هنا لما ابتدينا نطور في الري اللي هو بالتنقيط العادي او بالرش العادي، وكانت المحابس ساعتها يدوي بتتفتح يدوي او بتغلق يدوي، حولناها لمحابس كهرباء. حسبنا الووتر ريكوايرمنت لوحده، حسبنا الريتس اللي ما هو محسوبه لكل حوض او لكل مساحه مرويه، بحولها لزمن، بحط الزمن في كنترول بانل. الكنترول بانل بقول له اروي الزون ده 1 ساعه، اروي الزون ده نص ساعه، بيقفل ويفتح ويرجع اوتوماتيك، يقفل ويفتح ويرجع اوتوماتيك. هنا هو احسن من الري بالتنقيط العادي لان ما فيهوش عماله يدويه. في الاريجيشن سيستم كله المشاكل الاساسيه بتاعتنا هي العماله. فاحنا خلاص احنا بعدنا عن العماله، بس بتقابلني بعض الاوقات تغيرات مناخيه زي اللي بتحصل لينا في يوم حر جدا وانا عامل الشهر كله على 5 دقائق، يبقى اليوم الحر ده هيبقى ستريس على النبات. يوم شويه مطره وانا كنت عامل 5 دقائق عشان المطره دي هتحط كميه ميه زياده وهو الري هيشتغل عادي. يعني بقت عندنا بعض من المشاكل. احنا لو بصينا للنقط اللي هي البن دي، ده المفروض ان انا ارويه اللي هو بالحسابات اللي انا اعمله علشان تبقى كل الارض او عمق الجذور كله بنفس عمق الميه ويبقى فيها انتظاميه. لما انا حطيت الري بتاعي العالي ده تحت الكهرباء هيبقى اللي هو الاخضر ده اللي هو ما بيتم تطبيقه فعلا. الفرق بين الاثنين كميات الميه اللي انا بفقدها. انا كعاطف ما ببصش لكميات الميه ككميات الميه بس، ببص لكميات الميه حضرتك فيها اسمنت، حضرتك فيها طاقه، فيها استهلاك للشبكه. كل الميه زياده دي انت بتدفعها، كانك بتدفع مثلا 10000 جنيه عشان النبات يستفيد بيهم، تطير منهم 7 تحطها في الارض بعيد عن النبات. مع الوقت عشان نعمل تحسين لمحابس الكهرباء دي ابتدينا نعمل السنسورز. السنسور ابتدى يجي من بعض الجهات، في طبعا كل الناس تقول لك انا هركب سنسور. اقول له خلاص انا موافق انك تركب سنسور، بس انهي حاجه؟ في سنسور من ابو 10 جنيه في الفلكي، وفي سنسور ب 10000 جنيه احنا لسه جايبينه، هوريه لك دلوقتي، جاي من امريكا. ده بيعمل حاجه وده بيعمل حاجه. فاحنا ما نساويش الشبكه ام 5000 جنيه زي الشبكه ام 100000. فاحنا بقينا نركب سنسور في التربه. السنسور ده انا زودته جنب الكنترول بانل الثاني، بحيث ان السنسور ده يبقى حساس للرطوبه، اللي هو الكنترول سويل يوجر كونتنت، او يعني السنسور يوجر كونتنت لكميات الرطوبه اللي في الارض. دون العادي خالص باللوحه. اللوحه انا مسكتها بعد ما حسبت الاحتياجات المائيه، بس انا بقول لك احسبها بالطريقه الصح قبل ما تطبقها عليها. بتفتح الفالف بتاع المفعول اللي برضه انا المفروض احاسبه صح علشان يدي للشبكه بتاعتي ال5 دقائق او ال10 دقائق. وحضراتكم شفنا الفواقد اللي هي حصلت معانا. طبعا الفواقد اللي حصلت معانا دي انا عملنا ديفلوبمنت للشبكه الكهرباء دي، حطينا سنسور.
5 دقايق.
حاضر. لا ما احنا اخر واحد حضرتك حطوني عشان حاضر. احنا حطينا السنسور ده على مع حساس على الكهرباء. فلما تيجي الكهرباء تشتغل وتجد ان السنسور ده اداها مثلا ان الرطوبه 6، انا مبرمجه على ما بين ان هو يشتغل من 7 ل 12، فهو يقوم على طول شغال لحد ما يقوم فتح شبكات الري بتاعتي لحد ما يوصل ل 12، وبعدين يرجع تاني من 12 يرجع يشتغل تاني، يرجع يوقف عند 6، ولو جاله مطر قبل كده يوقف عند 6. فانا ربطت ما بين الكهرباء وما بين العوامل الارضيه والمناخيه. احنا مش هنفوت في الشرح كتير عشان الدكتوره. ده طبعا شكل السنسورز اللي هو بيتحط في دي انواع مختلفه، والحمد لله عندنا محطه وادي النطرون عندنا اكثر من تجربه شغاله في السنسور، والبدايات بتاعت النتائج ابتدت تيجي ان شاء الله باذن الله، وتكتب التهريب على اعلى مستوى. يعني حاجه بسيطه جدا. بدل حضرتك شكل التربه. شكل التربه خدت كميه ميه 59.6 لو هي من غير السنسور. حط السنسور فيها قللت ل 16.5، يعني وفرت ميه ووتر سيفنج ب 72.2. في تجربه كبيره عملناها في وادي النطرون تبع الجامعه الامريكيه وتبع المعونه الامريكيه، بس هي للاسف وقف الدعم بتاعها رغم اننا احنا جبنا احدث اجهزه على مستوى العالم. الفكره ان احنا عايزين نعمل مليون فارم نتحكم في الاب ستريم بتاع الترعه. فده الفكره بتاعتنا. فبعد ما اخذنا المشروع احنا ركبناه في وادي النطرون، وكان فيه وحطينا محطات ارصاد جويه. احنا زرنا امريكا واشنطن يونيفرسيتي، شفنا السمارت إيريجيشن، وشفنا كمان الاجريكلتشر السمارت اجريكلتشر، لان السمارت إيريجيشن جزء من السمارت اجريكلتشر شفناه. انا هنا عشان هنشتغل على السويل مونيتورنج، هنعمل BH وهنعمل BC وهنعمل درجات الحراره عشان نقدر نجيب كميات الرطوبه او الرينج اللي انا هشتغل فيه يفتح ويقفل اوتوماتيك. هو المفروض او الفكره الاساسيه ان هو اول ما يحس الحساس في التربه ان هو قرب لنقطه ان هو يروي، يفتح لي الترومبه اللي جايه من الترعه على بعدين الترومبه اللي جايه من المسقى، وبعدين يفتح شبكات الري الداخليه. طبعا احنا في وادي النطرون كنا عاملين على موديل صغير على حوض، ومن الحوض يفتح شبكات الري لحد ما تتم التجربه. ادي هي المحطه، التجربه دي تمت على 3 مناطق دكتورنا، وادي النطرون تبع المركز، وفي محطه في النوبريه ومحطه في الاراضي السوداء جنبنا هنا في القليوبيه. احنا ركبنا محطه ارصاد حديثه لانتاج 2025 عشان نحسب الاحتياجات المائيه الووتر ريكوايرمنت بتاعتنا احنا ونقارنها بالنتائج اللي بيعملها السنسور. دي المحطه دون السنسور هو ده احنا بندفنه جنب التربه مش في العمود بتاعها. السنسور دون متر ونص تقريبا، متر 20 سم، كل 20 سم بيدينا اشارات بالبي اتش والاي سي، فنقدر نتحكم والتمبريتشر، فنقدر نتحكم في شكل الرطوبه، نقدر نتحكم في الملوحه، في السماد، نعرف كل المشاكل واحنا عارفينها. وكمان هو بيدينا ابلكيشن على الموبايلات بتاعتنا. ده شكل السنسور لما ينزل في التربه ازاي يوزعها، لان السنسور لو ما اتحطش صح مش هتبقى الدنيا صح. الميزه في السنسور اللي احنا عملناه واللي احنا اخترناه ان هو بيظبط نفسه مع اي نوع تربه هو بيقابله. هو اول ما بينزل للتربه هو بيكتب ان الفيلد كباستي بتاع التربه دي 100، وبيكتب الولدنج بوينت 0 ما بين ال 100 وما بين الزيرو الافيلبل ووتر، بياخد النسبه بتاعتها وبيستوي بيروي. برضه هنا بقدر اعرف الاستهلاك، بقدر اعرف المعدلات اللي انا بقدت فيها ميه اكتر من اللازم وايه اشكالها، بقدر اعرف المشاكل بتاعتي. مني موجوده عندي اكتر من سنسور في المساحات بتاعتي، ممكن يبقى فيه كسر في حته او في الثانيه من القرايات بقدر انا اعرفها من نسب الرطوبه. ان في بعض من المقارنات حصلت، دايما احنا وجدنا اعلى انتاجيه تحت، لو احنا استخدمنا نظم ري بالتنقيط دايما بتبقى تحت البصر، ودايما بتبقى تحت البصر، دي اعلى انتاجيه لجميع المحاصيل. في حاجات حديثه عايزين نعملها وان شاء الله هنكتب فيها بروبوزال من المركز ومع مدير الشاب الجديد بتاع المعهد. حاجات حديثه لسه هنجربها. في حاجات دلوقتي يا دكتور بقت تنحط على طول جوه الساق وخصوصا في العنب، وبتتحط في المحاصيل، بقت احدث من اللي احنا بنقوله. عندنا مشاكل او تحديات اللي بتلاقينا في مصر يا فندم هو عدم الفهم. مش عدم فهم المزارعين بس، هو الفلاح عشان هي بقت النغمه دلوقتي كل واحد يقول لك ايه التكاليف الثابته التكاليف الثابته التكاليف الثابته. ما عادش الكلام ده، الفلاح عايز يشتري بس يضمن الانتاجيه العاليه. والحمد لله هي الانتاجيه العاليه. الفرق ما بين اللي هو نظم الري الحديثه والنظم السمارت ايريجيشن ما هياش كتير على الفدان، انما التكلفه بتبقى قليله. في حاجه بس انا عايز اقولها مني، الدعم بتاع التجربه وين من يعني والجامعه الامريكيه وقفت، فاحنا عايزين نستكمل التجربه لان هي تجربه رائده نقدر نستخدمها. احنا دلوقتي معانا السنسورز ومعانا كل الاجهزه، احنا ان شاء الله هنحاول نعمل اقتراح ونقدمه لبعض الجهات او نشوف التمويل اللي هو يكمل مراحل التشغيل الجايه. في حاجات عامه من كان معالي الوزير دايما بيقول يجب دعم البحث العلمي بكل ما نملك. النتائج الاساسيه بتاعت الابحاث لازم يكون في ضمير البحث موجود. وانا من كتر الخبرات اللي انا اكتسبتها اخيرا في السنتين الاخيره في التعامل مع ناس كتير من ضمنهم قيادات، فقلت احيانا كثيره اقناع المزارع اسهل بكثير من اصحاب القرارات. فظاهريا مقتنعون وقراراتهم ضعيف تماما انتشار نظم الري الحديث. مش معنى ان انا هدفع فلوس ان انا هاخد في الاخر ووتر سيفنج. انت ممكن تدفع فلوس وبرضه ما تاخدش ووتر سيفنج، لان لو هي حتى مش الصح وانت ما وجدتش الاستخدام الامثل للووتر سيفنج يبقى انت هدرت الفلوس. ده الحاجه بقى الكيس ستادي الاساسيه كنت هنساها، هي اهم حاجه دي الزيتونه دي. ان وزاره الري يا فندم قامت بتطبيق اللي هو السمارت irrigation از ووتر مانجمنت تولز مع الفلاحين. المزارع دوت اسمه احمد جابر، كان جه الاول بس كان بيشتغل في الري بالغمر، اتحول للري بالتنقيط في الاراضي الطينيه، عشان ما حدش يقول لي الاراضي الطينيه وبنعمل والصرف هناك قل والحاجه بقت فل والميه اللي قال عليها الدكتور محمد شعبان ما يقلقش. الراجل ده كان شغال ب4 فدان وعمل ري بالتنقيط. لما ابتدى يتحسن هو في الري بالتنقيط والناس شافت بقى ايه الوزير رايح يزوره وبتاع واحنا رايحين جايين عليه، الناس كلها بقت عايزه تعمل ري بالتنقيط يا دكتور. فراح هو اشترى الخراطيم وراح هو عمل ورشه وصلت لحد 6000 فدان اسمه احمد جابر. احنا عملنا له ادي السمارت سنسور، عرفناه ازاي يستخدمه، عرفناه ازاي يستخدم البنك وبقى شغال عليه. هو في الحقيقه ما بيسوقش للسمارت، هو بيسوق للخراطيم واللبه وبياخد المكسبين. بس حطينا في دماغهم او حطينا في المنتال بتاعهم ايه هو يقدر يعمله بالسمارت irrigation. ده كان واحد من قصص النجاح اللي موجوده في مصر. الثاني الراجل ده كان غلبان قوي. الراجل ده عملنا له ري بالتنقيط لوحده، بسماه في كتاب انا لسه عامله مع الدكتور احمد شوقي اسمه انوفيشن irrigation. ده عمل حاجه اسمها لو كوست irrigation. جاب خامات قديمه مستعمله لا فلاتر ولا حزنون، هو حاطط ايه شويه خيش كده حوالين المصفر مع الترعه وبقى يروي هو وعياله. وده لينا زميل اسمه الدكتور ايمن اخترع الجهاز ده. الجهاز ده الاحمر يقول له الارض بتاعتك عطشانه، الاخضر ارضك كويسه، الازرق ارضك مليانه ميه. ابتدى ينزل يعمله واشتغل هو وعياله. لقى ان العمليه ماشيه معاه، نجح في زراعه البطاطس وزراعه الفراوله. راح خد بعضه لشركه احمد دياب في البحيره، شركه كبيره بتصدر الفراوله. بقى هو يجمع من المزارع اللي جنبه الفراوله ودخل كسبلاير لشركه احمد دياب اللي بقى يصدر من بره. الراجل ده ما عادش يبيع في السوق المصري رغم ان هو 5 فدان، هو كان معله بتاع 150 ولا 200 فدان بقى يصدرهم للشركه الكبيره. فالري هنا او السمارت irrigation هنا فتح بيوت ناس وابتدت الناس تشتغل في الحلقه دي.
شكرا جزيلا يا دكتور على
لا كل سنه وحضراتكم طيبين ونتقابل على خير ان شاء الله. وبقى عايزين نكمل التجربه، مش عارفين بقى عايزين نكمل التجربه خلاص بصوت رهيب.
شكرا بجد، البرزنتيشن جميله وقصص نجاح بجد.
الحمد لله هم قالوا لي
ايوه طيب احنا يعني طبعا احنا الوقت سرقنا برضه، فبس عايزين ممكن 5 دقائق كده لو في اسئله دكتور احمد ودكتور عاطف. عارفه ان كله خلاص دكتور شعبان.
عماد هيجيلك.
معلش انا جاي من الجيل بتاع الاكسل والداتا اناليسيس القديمه، يعني اولد فاشن داتا اناليست يعني. فاحنا عندنا حاجتين دلوقتي قدموا الدكتور احمد سمير كان بيتكلم على الارتفيشال انتليجنس وكان بيدي اكزامبل بحكايه الكيو اتش ريليشن وازاي نوزع الميه في التصرف. فانا عندي سؤال كان بيقابلنا واحنا شغالين بالطريقه القديمه اللي هي الكونفنشنال ريجريشن اناليسيس. كان في مشكله اساسيه لما يكون عندك البيانات بتاعتك يا اما كوريليتد او والمشكله الاخطر في ان يبقى في ارتباط بين البيانات وانت بتتعلم من الداتا. فاذا كان في ارتباط من البيانات هذا الارتباط ليس حقيقي. اوقات الناس اللي اشتغلت في الاحصاء ممكن يبقى في مجموعه من الارقام اكس ومجموعه من الارقام واي، ولما نعمل التيست بتاع الاحصاء يطلع لي انه في ارتباط. لكن مهم جدا ان يكون هذا الارتباط فيزيكالي عنده معنى، لانه لو في ارتباط بدون معنى، يعني انا فاكر كويس قريت مره في الكتاب ان هم عملوا ارتباط السيارات اللي بتمر في الشارع وعدد السحب اللي بتمر في نفس الطريق فوق. ولو ان هناك علاقه يعني ماثيماتيكالي في علاقه. فانا عايز اعرف، انا مش يعني انا فعلا مش عارف ازاي الارتفيشال انتليجنس هيتغلب على الحكايه. يعني لو في كورليشن خلاص، لكن لو في كورليشن وهو فيزيكالي ملوش معنى هيعرفوا ازاي؟ ده السؤال الاولاني. السؤال الثاني للدكتور عاطف، لا هو حضرتك قلت انه السنسورز دي والسمارت اريجيشن ان هو بيحاول يكتشف العلاقات بتاعه عناصر الكروب الووتر كونتنت بتاعت التربه. انا عندي سؤال، الطريقه القديمه اللي كنا بنحسب بيها الفتره بين الريات، انا بحسب زي ما حضرتك قلت بالظبط البي اف كيرف والووتر كونتنت، وابتدي اعرف عندي الفيلد كاباسيتي كام، وعندي الويلتنج بوينت كام، او عندي الريدلي افيلبل ووتر كونتنت، واقسم الكلام ده على الايفابو ترانسبيريشن فيطلع لي الفتره بين الريات. حضرتك عن طريق السنسور بتقول على طول الراجل ده لما بينزل السنسور على محتوى رطوبي معين السيجنال بتروح وبيفتح السيستم. هل هناك دراسه حسبت ده؟ يعني لو انا اشتغلت بالطريقه التقليديه والطريقه المودرن اللي هي السمارت، هل هناك فرق كبير؟ لان انا شايف انه برضه المكان اللي هحط فيه السنسور، ما انا عندي مساحه من الارض مثلا 20 فدان 50 فدان 1000 فدان، فانا مش هقدر احط لكل متر مكعب مربع هحط سنسور. اكيد هبتدي اعمل سلكتيفيتي واحط مواقع. هي نفس المشكله اللي كانت بتقابلنا علشان اخد البي اف كيرف واشوف الووتر كونتنت هنا والووتر كونتنت هنا والووتر كونتنت ده كله برضه بيبقى فيه نسبه خطا كبيره. فهنا في خطا ومفهوم، وهنا في نسبه خطا مفهوم. قد ايه المقارنه بقى؟ شكرا.
طيب هو بالنسبه للماشين ليرنينج او النيو تكنولوجي دي، هو يعني بدون دخول في التفاصيل التكنيكال اللي هي جواها بتشتغل ازاي، بس هي الفكره كلها زي ما حضرتك كان في الاكسل بتعمل ريجريشن، فكان في درجات من الريجريشن دي، كان في لينير ريجريشن، وكان ممكن ايكويشن 1 ديجري في سكند ديجري، في كان بولينوميال وفي كان حاجات. تمام، هو التكنيك نفسه الماشين ليرنينج مختلف جدا. يعني الريليشن شيب اللي بتطلع مش ريليشن شيب حضرتك تعرف تكتبها في ايكويشن، يعني هي بتبقى زي بلاك بوكس. يعني عندنا كورس على سبيل المثال هو بلاك بوكس موجود بيطلع جوه الريليشنز، الايكويشنز هتتكتب بس بتبقى يعني ممكن توصل لعدد كبير جدا من الصفحات، يعني فبتبقى عباره عن بلوك ده بيقدر يدخل جوه الانبوتس والريليشن موجوده جوه، هو جواه بقى العديد من المودلز. يعني على سبيل المثال عندنا كورس من اسمها هي عباره عن غابه انا بعمل فيها شجر ده عباره عن كل واحد منهم موديل صغير. فالداتا لما تدخل بتتقسم على الموديلز دي، وكل موديل لوحده بيبقى مستقل بذاته، وبيقدر يديني اوتبوت، الاوتبوت شكله عامل ازاي، ويقدر جواه يقسم نفسه ويعمل فاليديشن وكاليبريشن لنفسه. تمام، يعني هو اوريدي انا دلوقتي عندي موديل بيكاليبريت ويفاليديت نفسه قبل ما يطلع لي الاوتبوت اللي انا بفاليديته بانسين داتا. الموديل حضرتك شفته معمول له فاليديشن بانسين داتا، ما دخلتش خالص في تريننج داتا. يعني الموديل ما شافهاش خالص، طلعت لو هنقول كورليشن طبعا حضرتك بتتكلم على السيجنفكنس، طبعا لازم طبعا لما اطلع في كورليشن لازم معاه سيجنفكنس وغلط.
لا انا سامعني لو طلع لي ماثيماتيكالي مجرد باي لاك باي تشانس طلع انه في ارتباط او في علاقه بين سين وصاد، لكن هذه العلاقه لا يمكن تحقيقها في الطبيعه، لا يوجد سبب يربط سين وصاد. ازاي انا اديتكت دي من الاول واعرفها؟ يعني انا لو عملت رن من البيانات هيقول لي انه في علاقه بين سين وصاد، لكن فيزيكالي ما فيش علاقه.
انا كنت قايل ان انا من الاول عارف العلاقه بين سين وصاد وبالتالي بديها
ما هو حضرتك وانا بطبيعه الحال لما ادرس اي موديل انا الفكره كلها عندي حضرتك هو كانت المشكله كلها ان في محطه ميه موجوده في المكان ده، وانا بفتح البوابه وعندي ووتر ليفل هنا، الووتر ليفل كان موجود يحقق الاكتفاء عند المحطه دي، بس الووتر ليفل فعلا عند المحطه ما كانش في الليميت اللي هو يسمح لها تسحب. تمام، فكانت الفكره كلها ان انا عايز اربط الجزء ده بموديل حضرتك ممكن تعمله بالانسان بس مش هيطلع لحضرتك نتائج دقيقه او موديل يقدر يجمع في كل حاجه او يقدر يتعامل مع الكونديشنز المختلفه زي ما يبقى في ماشين ليرنينج. الانبوتس بقى اللي بجيبها كلها مثلا على سبيل المثال انا ربطت تصرف الصدر العالي، ربطت حافظ والدوري السليم وفاريبلز كتير جدا. ماشي، صعب قوي ان انا اعالج سيل او بالطريقه دي. البوتنشال العاديه ان انا اربط 12 انبوت باوتبوت واحد بس تبقى صعبه.
بيتعامل مع البيج داتا برضه.
طبعا يعني احنا
ده بيدي مور
ما هو طبعا لو دخلنا بقى في موضوع البيج داتا طبعا حضرتك
ما هو دكتور، ما هو انت سؤالك اصلا سؤال بعد هو الفكره في ان انت بتقول بتفترض ان انا جبت داتا وانا مش اصلا ما عنديش الرؤيه ان هي فيزيكالي كونكتد، لا تعبر عن فيزيكال فينومينا، لكن البدايه لازم تبقى كده اصلا. انا بروح
انا بتكلم على الكيس بتاعت الكيو اتش ريليشن اللي احنا بنشتغل عليها. انا عندي 50 نقطه، انا لما هاخد البيانات بتاعت 50 نقطه دول وارد جدا انه في بعض النقاط يبقى في يعني فيك كوريليشن. في الحاله دي انا متخيل، انا ما اعرفش، انا عشان كده بسالك، انا متخيل انه الموديل هيبتدي يدخل معاه في الاعتبار ان هناك علاقه بين سي وصاد، وهذه العلاقه فيزيكالي غير موجوده.
يعني انا هو
هيعمل ايه بقى؟
لا هو مش هيعمل حاجه، هو مش هيعمل حاجه،
مش هياخدها في اعتبار،
لا هياخدها في اعتبار بس مش هيفسرها بان مفيش علاقه هو عليه علاقه. انا وجهه نظري انه النهارده انت لما جبت الريليشن او جبت الداتا بتاعت الكيو والاتش، في ريليشن ما بين الكيو والاتش احنا متفقين فيزيكالي فيه، لكن الكيو والاتش دي في حاجات كتير جدا ممكن تاثر عليه، يعني اسمه لينير، حتى اسمه يعني 2 or 3 فاريبلز كتير جدا. النهارده انا عشان اكون نيوميريكال فورميوليشن للفيزيكال فينومينا اللي بتعبر عن العلاقه بين الكيو اتش في لوكيشن معين، محتاج اجيب كل الفاريبلز بارامترز واحده واقيس كل واحده. اللي بيحصل هنا وجهه نظري ان هو بيعمل ايه؟ هو عنده 2 فاريبلز وفي huge number of measurements، فبالتالي هو لما يجي يجيب الريليشن بيست على الهيوج نمبر اوف ميجرمنتس، هو خد في اعتبار كل الفاريبلز الاخرى الهيدن اللي انا مش عارف اقيسها، لان هي مش بتعبر عنها في الايكويشن.
ده التريننج اللي بيتعمل ده
بالظبط،
هي
ماشي كده. بس انا هنا مش بتكلم على الكيو والاتش، انا متصور ان الموضوع بعد ما بربط الكيو والاتش كل واحده هيبقى عندي رؤيه للسيستم كله، زي ما الدكتور قال هيبقى عندي علاقه بين النقطه اللي في السد العالي والنقطه اللي في قناطر بوضيات ولا فالعلاقات دي بقى مش ما كيو والاتش عند نفس النقطه دي، لازم يكون في فيزيكال ريليشن، دي مفيش فيها جدال. انا بتكلم لما اجي اربط المنظومه بالكامل مع بعضها، وارد جدا انه يبقى في ريليشنز موجوده، الريليشنز دي غير حقيقيه، هي مجرد باي تشانس.
ما هو حضرتك مش اولا الموضوع معقد شويه، لا هو موضوع معقد جدا، يعني هو موضوع مش
هو انت عندك حاجه، وانت عندك حاجه، بس هي الفكره هنا برضه ترجع للاصل، انت جبت الحاجات ازاي؟ هل انت النهارده لما بتقول انا قست نقطه عند اكس 1 جبت كيو اتش ونقطه ثانيه فور داون ستريم على بعد 10 كيلومتر وطلع كيو اتش، وعملت بقى لما شفت السيستم جبت علاقه ما بين هنا وهنا. ايوه انت
انا لو هشوفها خلاص، انا بس خايف، انا مشكلتي ان انا مش عارف ايه، انا مشكلتي ان يكون هو بيشتغل وانا مش شايفه.
لا هو حضرتك هو قالها دي لازم عندنا دي قابلتنا، بس طبعا مفيش وقت اللي انا ادخل في الحلقه ولا بسيطه. حضرتك الميه لما تطلع من السد العالي تاخد وقت قبل ما توصل للقنطره او توصل لحاجه، فطبيعي كانت اللجنه بتاخد في الاعتبار. يعني الموديل على فكره الراجل فارس موديل على سبيل المثال بيطلع الاوت لايرز، اي رقم لو حضرتك حطيته له غير منطقي هو بيشيله اوتوماتيك، ما بيتعاملش معاه حتى في التريننج ديتا، هو بيشيله مش في كل الحالات، ما انا لازم اشيك ورا. تمام،
هو بص عشان هي كومبليكيتد شويه واحنا داخلين على كريتيكال تايم،
يعني ممكن بس نسمع اجابه الدكتور عاطف بعد اذنكم، اجابه الدكتور عاطف ونوقف عشان نعمل راب اب كده لليوم وتلحقوا تشوفوا نفسكم بس قبل ما نفطر ان شاء الله.
دكتور عاطف قدامي فيري شورت، الله يخليك.
فيري شورت يا دكتور. الدكتور محمد الشعبان مدير معهد قوس الصرف بيدينا على طول. تمام يا فندم. هو دكتور محمد، احنا قبل ما نحط السنسور ده بنعاير اماكن في التربه، فبناخد الرينج اللي هو يشغل الماجورتي بتاع التربه، وده بيوفر كميات ميه اكتر حتى كمان من الري. لو في شحن اكتر انا ممكن اشحن اكتر. وانا عامل افلام
عن ازاي تظبط السنسور. هبعتها لحضرتك. كل عام وحضراتكم طيبين.
شكرا جزيلا. يعني لكل بقى البرزنترز مش الاخيره بس. ويعني اشكركم، ويعني نعمل ركب سريع كده لليوم. السيشن الاولانيه كانت التايتل بتاعها مودرن اريجيشن تكنيكس اند سويل مانجمنت. كان معانا 3 presenters presentations efficient irrigation system, direct pivot and smart irrigation. Then closed chain protocol, complete saline water irrigation, successful implementation of rationalization irrigation water irrigation. Objective can explore the potential of modern irrigation techniques on water productivity في السيشن ككل. We can conclude in using smart technologies in agricultural management projects to adapt climate change, generalization, the use of automated systems in agricultural operation to ensure the continued production in times of crisis and disasters, yield improvements in clay and sandy soils, enhanced soil properties, improve nutrient availability, adapted with using saline water in irrigation. والrecommendation في السيشن الأولانية further research needed for scaling up field applications. Biocar and nano biocar are effective for sustainable agriculture. Application improves water efficiency and soil fertility. I believe in further research دي يعني مطلوبة الحقيقة في كل السيشنز. السيشن الثانية كانت بعنوان water use and recycling innovations. وكانت تهدف اساسا لديفلوب او يوز نون تراديشنال ووتر ريسورسز، سواء من الريوز او الووتر هارفستنج او الاربن ريوز. وكان يعني الكونكلوجن بتاع بالنسبه للووتر هارفستنج presentation, it can be concluded that rainfall harvesting using low-cost techniques, artificial mountain lakes, can enhance the efficient use of water in arid regions like South Sinai. Rainwater is seasonal, therefore this water should be integrated with the groundwater for sustainability. It is recommended to apply this technique in other areas similar nature. يعني بيتهيألي موضوع الووتر هارفستنج ده من المواضيع المهمة جدا. وانا يعني حسب المعلومات هو بيحصل في غير في سينا، طبعا في مناطق ثانيه في الصحراء الشرقيه. والكونكلوجن ده electrochemical techniques is an efficient and very effective method for water treatment. ده بالنسبه طبعا للموضوع بتاع الريوز. واخر سيشن هي كانت بتتكلم عن التكنولوجيز، كانت برضه هي بعنوان Artificial Intelligence and Drones for Water Resources Management. وهي كانت فيها 3 presentations. واحده address الدرون systems for digital agriculture، والثانيه كانت artificial intelligence for advanced water resources management، والاخيره case study digital tools for water productivity in Egypt. والobjective بتاع السيشن explore the potential of artificial intelligence and using drones in enhancing water productivity. Identifying innovative applications of artificial intelligence and drone in water resources management. والحقيقه ان can conclude by utilizing the power of artificial intelligence and drones, we can revolutionize water management in both agriculture and environmental contexts, and data-driven solutions to address the world's growing water challenges. We recommend establish a national framework for irrigation, integrating artificial intelligence and drones in water resources management, and develop and implement artificial intelligence-powered decision support systems for water management. Develop training programs for water professionals on artificial intelligence and drones-based water management. ودي برضه من النقط اللي كانت مهمة يعني يبقى في expertise يشتغلوا على الحاجات دي. We are looking forward to further cooperation مع الجهات المختلفة. شكرا لكم جميعا.
شكرا دكتورة، شكرا جزيلا. يعني بس انا حابب في الاخر كده ان شاء الله قبل ما المغرب جدا ان شاء الله وير اباوت يعني اشكر حضراتكم جدا على يعني يوم كان طويل ولكن الحقيقه اعتقد ان هو كان برودكتيف جدا فيري فروتفول. سمعنا يعني الحقيقه برزنتيشنز اكثر من رائعه فرايتي اوف توبكس ولكن كلها بتصب في الاوبجكتيفز اللي احنا كنا بنتكلم فيه في اول اليوم. احنا we need to know, we need to exchange وان احنا we need كمان ان احنا تبقى عندنا القدره على ان احنا to use the best practice والcase studies اللي هي successful علشان نقدر نبني عليها ونكمل في فكره how to do proper management for our water initiative. الحقيقه اعتقد ان احنا النهارده قدرنا نوصل لمرحله كبيره جدا من الانفورميشن على ايه هو available in terms of research, in terms of project, in terms of case studies, applications. وهو ده يمكن اللي lead us tomorrow ان شاء الله ان احنا how to use this in terms of يعني policy and strategy. بكره ان شاء الله هيبقى عندنا يوم برضه اعتقد very important من منطلق انه and also on target نقاط مهمه جدا. من اهم الحاجات التكنيكال بكره ان شاء الله موضوع climate change resilience في موضوع الagriculture water management. الجزء بتاع الكاباسيتي بيلدينج والإديوكيشن والرول بتاع الديفرنت انستتيوشنز سواء الريسيرش سنتر سواء اليونيفرسيتيز will also be addressed. ومن اهم بقى السيشنز ان شاء الله اللي هتبقى في اخر اليوم هي فكره how to يعني formalize a kind of a platform for cooperation. International national cooperation with strategies زي فعلا احنا to have at the end a real impact on the current situation based على فعلا الشغل اللي ممكن يكون اتعمل وهيتعمل. فانا اعتقد ان شاء الله بكره هيبقى يوم كونكلود اللي احنا ناقشناه النهارده. I think we have benefited a lot from the discussion ومن presentations. بشكر كل الحضور، بشكر البرزنترز، بشكر كل الناس اللي شاركتنا النهارده سواء فيزيكالي او اونلاين. واتمنى ان شاء الله ان احنا برضه نكمل بكره بنفس الحضور وان شاء الله تكون افضل. وبشكر حضراتكم كل سنه وانتم طيبين. ويعني اعتقد كده انا حاولت استخدم كام دقيقه لغايه المغرب لكن حضرتك هتبدا ولا يعني ولا لسه شويه؟ شكرا لكم ونشوفكم بكره ان شاء الله على خير بعد الفطار باذن الله. شكرا.